True, true. Welcome, everyone. Good morning. Good morning. Can you hear me? Okay, good, good. So welcome to our second session of the Digital Transformation Accelerator. So today we're going to talk about the digital innovation for advancing research in the food, land, and water systems. So before to start, I will start with a reflection about what has been happening over the week. So I keep hearing over in the plenaries and in different side sessions about what we do at the CGIAR, right? We do research for development, but we don't do that alone. In order to achieve development, we need our partners, we need the different people we work with. And in particular, I was participating in some of the sessions that talk about the transformative partnerships. And in those sessions, they ended up concluding that they can accelerate research by using digital tools, by engaging more with the youth. They talk about how we can reach massively farmers through digital tools. How can we really accelerate many of the process that we do in doing research for development in agricultural research? So it's a pleasure for me today to introduce what we're going that we with a wide range of partners representing different sectors. We're going to showcase topics related to. Listen carefully, yeah. Real-time data, digital twins for decision-making in water management, artificial intelligence-driven approaches, digital soil mapping, remote sensing, and machine learning. So I think that all those tools will help us to definitely accelerate research in agriculture, and this is what we definitely want to do with our accelerator, to help the CGIAR to stay ahead of the curve in terms of digital trends, digital technologies. So with that, I will give the floor to Anna Mueller, my colleague, who will introduce the first presenters.
Good morning, everybody, and also welcome from my side to the session. We will start with a keynote session. We have two distinguished speakers that I'm happy to introduce here. We managed to get Boniface Akuku to have a keynote session and also Morgan Kabir. Let me briefly introduce the two speakers. Boniface is called the grandfather of digital agriculture in Africa and seems to be very famous. I still will introduce him briefly because we have a global audience here, and I guess colleagues from Asia and Latin America might not be so familiar with the digital landscape here in Africa. So Dr. Boniface Akuku is an expert in digital agriculture, data ecosystems, generative AI, and working a lot across sectors and giving strategic consultancy and advice on digital transformation. He has been formerly the director for ICTF at Cairo, where he had a huge impact on the digital transformation of the agricultural sector. So Boniface will talk about the pillars of the digital ecosystems that are needed to drive digital transformation. We also will have Morgan Kabir as a keynote speaker. Morgan is the Global Engagement Director for Busara. Busara is a behavioral research center based here out of Nairobi. And they're working a lot around behavior research and human-centered design to solve pressing problems across sectors as agriculture, health, education, and others. And she will give us a more deep dive into behavioral patterns and adoption challenges around digital agriculture that they researched also across several countries here in Africa. So we will have two presentations and then we will have room for questions, discussion from the audience. Boniface, please, the floor is yours.
Okay. Does it work? You can hear me? Okay. If you can hear me, that's okay. Okay. Let the technical team wait. Okay, I think that's better. Yeah, I think I've introduced, and because of time, I'll go straight to my presentation. I'll be talking about driving digital innovation for agricultural transformation. Where should this go to? Just say next, okay. I was told there's a problem with this, or it's working now. Okay, go back. Okay, so I will talk about what are the building blocks for digital agriculture, because when you talk about transforming agriculture, it's important to understand what are the pillars. What do we need to really transform agriculture digitally? I think McKinsey did a study in 2019, and they said that agriculture is the most conservative sector in the world. And therefore, if you're dealing with a conservative sector, then it's not like the finance sector, which is not conservative, the technology, which is not conservative. And therefore, I'll talk about 5 building blocks. Number one, you need to develop digital infrastructure, because everything runs and rides on infrastructure. But it's really best if you have a public digital infrastructure, or even have the thinking about it. And in this case, what it helps you is to build dynamic data platforms. It helps to create, for example, digital farmer registry, digital farm registry. You integrate payment system where possible by bringing the private sector ecosystem. And also it will be important also to look at what are the framework that exist, what are the policies that exist. And the second building block is to have a governance structure, because most times that people collect data and they keep it. Now, I'm told that is not like wine. I've never taken wine, but I'm told that wine, if you bury it, you hope it will get sweeter with time. But data do not get sweeter by burying it. Data gets sweeter when you make it usable, when you turn data into a service. And that can only happen if you have a governance framework. And this can also happen if you have champion leadership, people who are passionate about digital agriculture, people who are passionate about turning data into services, people who are passionate about how do I solve the problem using digital and using data. And the third building block is it's important to have a roadmap and have a strategy, because this will be important for you to be able to have a clear pathway. How are you leading to the success? And most strategies are developed not around pain points. They are developed in boardrooms. And I would challenge us that if you want to build a good roadmap, a good strategy, please get your hand dirty, go to the field, build your strategies and your roadmap around the pain points. What are the problems you're trying to address? And then the other one is partnership. So how do we fund innovation, and how do we basically develop disruptive technology? Because agriculture is conservative, therefore we must disrupt it. And the last is leverage on emerging technologies such as AI, ML, and predictive learning. Next slide. Now, the second important thing at the slide comes that a number of you are from Europe, a number of you are from Asia, and I've seen a lot of import and export. Now, that sometimes do not work well with digital agriculture. Some of these tools work very well in Europe, in Asia. They don't work well in Africa. And one of the best you need to do is to understand and access the context. Context is very important. We are talking about different contexts here, context with digital low digital literacy, contexts that are rural with connectivity issues. And therefore, when you do an assessment of the ecosystem, one of the things you like to understand that what are the instruments that you need for you to succeed. And in this case, one of the things we do an assessment so that we look at the investment that you need. What are the investments needed in digital agriculture? The other thing you really need is technical assistance. Another thing really we need to understand, what are the policy environment? But again, other than that, also you need to come up with who are the stakeholders and what are their roles? Where is the role of private sector? Where is the role of public sector? Where is the role of farmers and producer groups? And then the most important is to understand the pain points. What are the problems? What are the resource problems? What are the production problems? What are the market problems? What are the enabling environment problems? After you do that, it gives you a chance to come up with strategies. And in the strategy, what we emphasize that please emphasize the value of data digitization and also prioritize innovation and also focus on scale and impact. And I want to say this, a number of times we talk about digital agriculture, People never focus on scale and but they are pilots. They are siloed things being done in one corner, in one place, which has no impact and no scale. If you miss scale and impact, then you are likely not to succeed in digital agriculture. Next slide. I'll just quickly run you through the Kenyan journey in less than a minute, so if I can manage. So this is how the Kenya digital journey started in 2013. And the first, as I said earlier, we actually work on having a digital infrastructure, and then we socialize the organization and the ecosystem with digital ag, because this is something which was foreign to them. How do you socialize them? How do they understand the importance of this? And then we realized that there was a need to collect different data sets, and we established a big data platform. And then after all that was done, we moved now to unleashing innovations. How do you turn data into a service? How do you turn data into a service through innovation? And we came up with a lot of innovations, 65 mobile apps. We came up with the mobile apps and different systems that are able to address the farmer pain points. And then we realized that you need to know your farmer, because a number of us are supporting farmers, but do you know your farmer? What are the value chain? Where is the acreage? Where is that farmer is? How do you say you will transform farmers if you don't know who they are? So the most important thing is that know your farmer. So we came up with a concept called KYF, know your farmer. And in the process, we managed to reach 6.5 million farmers. And then now we've had a roadmap, and we brought in the private sector under the 1 million farmer platform to come up, and because there are things that public sector can do very well, but there are things that private sector can do very well. So that nexus of bringing public sector and private sector together gave us a lot of achievement. And then in 2020, we now move to path to efficiency. How do we scale and how do we achieve impact? And in 2023 going forward, the focus will be deploying AI and deep learning. Okay, next. Yes, so there are three key pillars I think I've talked about them. Make sure that you organize your data, farmer data, farm data, stakeholders data, research data from different teams, and then digitize all that into a digital stack. And then, as I said, focus on innovation. How do you turn all this into a service? Farmers do not need data, farmers need a service. Stakeholders do not need data, they need a service. Research needs data. But how do you convert that data into a service? Next slide. Okay, so this is just showing you how they know your farmer works. So that is Kenya, where we have now 6.5 million farmers digitized. You can see where are they distributed? Where are those ecological zones? What are the, from there you can tell the nearest market, you can tell the weather forecast for the last 30 days, for the next 15 days, and you can tell them the historical weather data for the last 30 days, because you now know that you can tell the soil pH, you can tell the soil nutrients, you can tell everything around that farmer. And therefore serving that farmer becomes easy. Next. Okay, so the next just a slide showing you how Kenya organized their data through big data platform. The farmer data is very important. How do you maintain that data? The research data coming from pathologists, from entomologists, from breeders, and from all those doing research. How do you organize? Because for a long time, this data was in the head of the researchers in their laptop or their flash disk. How then do stakeholders, how does innovators access it, that they can innovate around it, turn them into services, unless they're organized and put into one place? And therefore looking at other data sets like remote sensing data, soil data, climate data, market data, all this data goes to one platform called the big data platform. But the gist of it is, how do you turn it to a service? How does researchers use it so that research becomes demand-driven? How does policymakers use so that they can make the right decisions? How does the extension, whether they're private or public, use this? And how does farmers and personally use it? So the gist of all this is to organize them, this data, but turn them into services. Next slide. Yeah, so this is an example of one of the services, the climate advisory services, where knowing the farmer, you have the GPS code of the farm. With that single GPS code of the farm, you can now get the forecast for that farm for the next 14 days using satellite in a 4x4 kilometer. So with that single GPS code in it, you can tell the historical weather forecast for that farm for the last 30 years. So you can begin to run climate models. You can begin to run suitable planting window models. You can begin to run pest and disease models. You can begin to run marketing models. Because you now know where that farmer is. So we built into what you call decision tree, where you now, it's called location-specific growth stage, because what does a farmer need to do at every stage of the crop? With that single GPS coordinate, you can now tell what a farmer needs to do, and that goes in as an SMS once a week. So this is a program funded by World Bank, Bill and Melinda Gates, with Tomorrow Now and Calro. Next slide. Yes, so with this is one of the impact. With this, from this innovation, what we realized that we now reduce the cost of delivering messages to farmers. And now also what happened, the farmer satisfaction improved from good to very good to excellent. And then also we find that the farmer reached started from 200,000 farmers to 5 million farmers. But most important, the behaviors of the farmers changed, because as there was engagement concern with the farmers, as the farmers began to see the impact of the advisory services, they began to adopt climate resilience practices, which they were never doing before. Next slide. How many minutes? 2 minutes. Good, I'll finish. I'll finish in 2 minutes. Okay, so again, this is an example of where we brought in private sector together. We brought 34 agri-tech actors into this space, work under one umbrella called 1 Million Farmer Platform, so that they could take their innovations to farmers. And that's what I was saying about partnership between public sector and private sector is very good. And you see, there are things that private sector can do very well, but they have to be enabled through a public sector. And therefore, they are leveraging the digital farmer registry to deliver their service to the farmers. Next slide. Yes, so I just want to show you a small case in Ghana. In Ghana, we took a different approach. We looked at the how do now focus on the agribusiness. And we're seeing how that is working. So the focus is how to bring all the agribusiness players together, and how can they be finance institutional market coordinators, and how do they now focus on delivering service as opposed to having a free service always. So we are testing that model. Next slide. Yes, so I think this should be the second last slide. So this should be fine. Now, this is where we're now saying, after organizing all this data from different sources into a big data platform, having leveraged historical data, now AI become a reality, because AI is data hungry, but it needs historical data, it needs organized data, and therefore now you can do things like fertilizer optimization. You can now advise which is the right fertilizer for your farm, because you know the farm. Which is the right application should apply, and which the crop you should plant based on the season. What is or how much is needed? How can you formulate the fertilizer? We can now do yield estimation. You can now do supply chain optimization. You can now do crop monitoring. You can now do credit scoring. You can now do market prediction, because now data is organized in a digital form. Now innovation has a space to be able now to drive transformation. Innovation now has a space to deliver services to the different stakeholders. The nexus between the private and sector coming together to deliver holistic services to the farmers. If there's no slide, I can stop, but if there's a slide, I don't know what's written in the other slide. Okay, this is what you know very well. Part of the technology is actually using drones. Actually, that's my farm, where we are flying a drone just to collect data and detect pests and diseases and assess crop health and all that. I think there's no more slide. Thank you.
Thank you, Boniface. Yeah. Thank you very much for this really insightful presentation. I really like how you present the different pillars of the digital ecosystem that are so relevant: data, infrastructure, governance, but you also clearly link it to the strategy and the context, and state the importance of context and knowing your farmer kind of at the heart of this. And maybe we allow for 1 or 2 direct questions from the audience before we move over to Morgan. I see here one, please.
Very nice. Sorry, my name is Chinyere Ikini-Jiganu. I'm a statistical geneticist from ILRI. I really enjoyed the presentation. My question to you is, I don't know if I heard correctly, that the farmer is the reporter of the data. So what's in it for the farmer? Do you do any form of feedback? Like, I just want to know, because you need to keep them engaged. So how do you do that? Thank you.
Is there one other question here? Yeah.
Thank you for your presentation. My name is Harrison Jamba from Agri-Food. I'm a data systems manager. One of the major problems that we have in every organization is know your farmer. Because you have many different projects working with the same farmer, but actually we do not know we are working with the same farmer. Do you, considering that Agri is based in Kenya, do you have an API for the digital data that Caro holds, that we can be able to pull the details of the farmer such that when one project in Agri is working on that farm and another one is working on the same farm, we end up knowing that actually it's the same person that we ended up meeting?
Thank you. Yeah, let's take these two questions, both going into the same direction of engaging farmers and the difficulties of knowing the farmers.
Okay, thank you. I hope you can hear me. Yes, so the first question is that how do you engage the farmer? Okay, so what we have done in Kenya, where we have 6.5 million farmer digitized, and even what I'm supporting other countries, is that the first thing is that these farmers, we know where the farmers are. But the model we use is where we used enumerators who are given a tool, they would go and then register the farmers, take their biodata, take the GPS code of the farm, know their education level, know what the value chain they're practicing, know what type of messages they prefer, what time they prefer. So we collect about 59 variables now, so that we know the farmer very well. Now, this was done through an enumeration process, which is a one-off, which gave us what we call a baseline. But now, we have engaged other strategies to maintain that database, because today the farmer is doing beans, next year is doing maize. So the different strategies that we have engaged is one, there's a call center where farmers can call and update their records. The second thing is what we call Agri-Food model, where now their young graduates have been engaged by the government, and each agripreneur is assigned 100 farmers. The reason why they are called agripreneur is because they are supposed to earn their income from the service they are offering to the farmers. Now, this agripreneur keep on updating the farmer records, collecting further data. The second thing we have done is that all these farmers are attached to a circle, where now they are at the local level, where now they can take credits and the transactions are kept. They are also attached to a cooperative. So there are different strategies to keep on engaging with the farmer. But also, there is a two-way SMS where farmers are sent messages, but they can also send messages back. Like they can report the planting dates, because you need to know the planting dates so that you can give them recommended advisories based on the growth of the crop. So several strategies are being used. And then we also have a model where we call engaging farmers with through what we call having them into groups, sending somebody to sit with them, getting feedback. We have people like 60 Decibel doing those studies. Busara is coming here, they're doing those studies, where you now get feedback from the farmers. Is the services answering your problems? Are you satisfied? What need to be changed? So different strategies have been used to engage the farmers. Personally, I used to sit in the sun and the grass with farmers, and I would send them an SMS, and I would ask them, did you understand what the message meant? They attempt they don't understand, and I would explain. One time I sent an SMS, I would like, if it is too much water in your farm, prepare drainage. And over 100 farmers told me they did not understand that. Then I explained what I wanted to say. And then they said, oh, you'd have told us if there's too much water in your farm, remove the water. Removing the water we know, but preparing drainage we don't know. So I mean, that's how you design systems, you design tools, you design services that are responsive to the needs of the farmers based on their capacity. So you have to get your hand dirty, go there, talk to them. So several strategies are there. The second question is about know your farmer. Yes, it's a problem, and that's why in Kenya we decided to sort it out. In Ghana, we are sorting it out. In Malawi, we have 3.5 million farmers digitized. In Ethiopia, it's being sorted out. In Africa, I think about 14 countries, we are trying to sort this thing out of know your farmer. Now, what we've done for, let me give the case of Kenya, because Kenya is mature in this case, with 6.5 million farmer digitized. That farmer data can be accessed. You just need to reach out to Calro, but we are trying to get out of the traditional methods of asking Calro to send to the farmer data in an Excel, in a PDF. Kenya is building a digital public infrastructure through federated learning, which you don't need to have the details of this one. You only need to build your service, leverage on that database, and offer farmers your service. For example, today, you can withdraw your money from the bank using a mobile phone. You don't have to, the telco who has your data do not have to share your data with the bank. The bank that has your money do not have to share your data with the telco. They're using a technology called federated learning, which allows any person to develop a service leveraging on that database. So ILRI can offer their service to the farmers without having access to that database. Only you need to build your service on the federated learning model. And that's how it's working. And that's what we are trying to do. And that's what we're encouraging other countries also to do. Thank you.
Thank you. Thank you for the reflections. And I think that's the perfect bridge for opening the stage for Morgan to give us a more deeper dive into how we can understand farmers and their challenges to use digital tools using behavior research. Okay, is this better? Oh, wow, that is a lot better. Hi, everyone. My name is Morgan Kabir, and I'm an engagement director at Busara. Thank you so much, Anna, for organizing all of this, and thank you so much, Boniface, for your presentation. It actually aligns perfectly with the information I'm going to be presenting today. So for the next 10 to 12 minutes, I'm going to present some of the key findings that we found from the digital grant, which we recently concluded in partnership with the Bill and Melinda Gates Foundation, 60 Decibels, and 5 different digital service providers. And so our work under this grant entailed designing and testing different small interventions and nudges to improve the adoption of digital services among smallholder farmers in sub-Saharan Africa and South Asia, using methods from behavioral science and human-centered design. So if you're working in the digital agriculture space, whether you're a researcher like me or a provider, my goal is that by the end of this presentation, you have a deeper understanding of nudges, behavioral science, human-centered design, and how these different methods can be applied to facilitate adoption. Next slide, please. Next slide. So just by way of a quick introduction, Busara is a research, advisory, and design firm focused on advancing and applying behavioral science in the Global South. What this means in practice is that we study why and how people behave the way they do, pinpointing the specific factors that drive their decisions and behaviors. We then design and test different interventions and nudges aimed at changing behavior, leveraging the different factors that we've identified. I'll provide a more concrete example of this later in the presentation. So we frequently work with different partners across the public and private sector, from governments, NGOs, and social enterprises, to study issues related to adoption. For example, in agriculture, we may try to understand why farmers aren't using a new practice or purchasing and using a new financial product or service. At the end of the day, adopting any new product or service is a decision, and nearly all decisions are driven by a complex confluence of factors. Next slide, please. So just to provide you with a little bit of background, digital services, as I'm sure many of you already know, have tremendous potential in reinforcing the climate resilience of smallholder farmers. There's a burgeoning body of literature, which I'm sure many of you are familiar with, focused on demonstrating how digital services can make farmers more resilient to the effects of climate change and improve their productivity, well-being, and overall livelihoods. However, in order for these digital services to reach their full potential, farmers need to adopt them. So for this reason, we are studying adoption under the digital grant, but through a behavioral science lens. So I'll acknowledge that studying adoption of digital services among smallholder farmers isn't necessarily a new field of study. And there are many studies out there that identify the challenges in this space.
But what we did for the digital project was we leveraged the challenges identified in these studies and looked at them from the perspective of farmer behavior. We were less focused on policies and products and more focused on a farmer's decision to use a given product. We were really interested in unpacking how different norms, biases, and preferences can drive or inhibit adoption. Relatedly, since we are studying norms, using a behavioral science approach allows us to study gender norms more explicitly and critically. So we know from past studies that gender norms can influence the adoption of digital services among women smallholder farmers. And if we don't incorporate and consider these gender norms in the design and implementation, then we can inadvertently create barriers for women in adopting digital services. So what we wanted to do under this grant was really understand gender norms and how they could be overcome or even in some cases leveraged to increase adoption among women. Next slide, please. So when I speak about digital services, I do mean that quite broadly. We've partnered with 5 different organizations that offer digital services, and at a very, very high level, they could be lumped into the 3 categories I have on the screen. So some of our partners provided digital advisory services to extension agents and farmers, providing them with information digitally on weather updates and harvesting a wide range of different information. Some of our partners offer digital record keeping services for extension agents. They're trying to encourage extension agents to use digital record keeping services to give them the data to provide farmers with more customized advice and services. And the last category that we have here, some of our partners provided digital advice to directly to smallholder farmers on things like market linkages and prices. So all of our partners had operations across sub-Saharan Africa and South Asia, and they all had questions on how to increase the adoption of their digital services. Next slide, please. So our approach to increasing adoption under the digital grant was to design and test different nudges. So I'm sure many of you in this room already know, but nudges are small, relatively inexpensive interventions aimed at overcoming key barriers. Our nudges pave the way for digital service adoption by either reducing or in some cases leveraging any noise that can pose a barrier. In our experience, nudges, the best and most effective nudges are really grounded in the context and realities of the end user, which in our case is smallholder farmers or extension agents. So what we wanted to do under the digital grant was to really gather a lot of rigorous evidence on the context that the smallholder farmers are operating within, trying to understand their beliefs, preferences, and biases, to really make sure that the nudges that we were designing and testing overcame barriers to adoption and were congruent with the context that they are operating within. So at the start of each of our 5 projects, we conducted qualitative research with farmers, where we posed open-ended questions with corresponding probes to really understand what the underlying barriers to adoption were, going as deep as we possibly could. We did include both men and women in all of our samples to make sure that we were able to determine different barriers by gender. We then took this information into co-design workshops with farmers and extension agents, where we presented them with these different barriers and conducted a series of brainstorming exercises to brainstorm solutions to overcome these barriers. We posed a series of how might we questions, did some story completion exercises with the idea that we would brainstorm these different solutions. We also presented the barriers that women encounter, which we found from the qualitative research, to make sure that we were incorporating their perspective into the brainstorming. And to conclude, the last phase of each of these projects was to, of course, test the interventions and the nudges that came out of the co-design workshops. We developed the interventions and nudges into prototypes, which we then tested in the field using randomized control trials and behavioral lab studies. This allowed us to make sure that the solutions that we were developing effectively overcame the barriers they were meant to address. Next slide, please. So for the rest of the presentation, I'm just going to provide just a few very, very high-level insights from this research. We uncovered so many findings from the 3 years of this grant with the different partners. Unfortunately, today I only have time to give you just a few insights, but at the end of this presentation, I will have a QR code, which will take you to a microsite for the grant, which will provide more information on some of the research that we conducted. The microsite also has a toolkit that provides more details on how we went about conducting this research for providers and researchers interested in conducting behavior change research. Next slide, please. So in this first example, we partnered with the Goat Trust in India to design and test different solutions to encourage women extension agents to use digital data collection tools. In the current process, the Goat Trust asks that their extension agents conduct data collection on the farmers in their communities using a paper and clipboard. However, they were interested in streamlining this process and having the women who they work with collect this data digitally, which would allow them to, of course, offer more customized advice to their farmers. So they offered the women subsidized smartphones and asked that they begin collecting data on farmers in their communities digitally. They're actually currently in the process of developing an app, but our research was just focused on getting the women to use their smartphones for conducting digital data collection on WhatsApp. So when we conducted interviews with the extension agents, we of course uncovered many, many barriers. I don't have time to really get into them today, but I can talk about two. The first one that I have listed here on the screen is trust. So we found that the women extension agents, whenever they would send their data on WhatsApp, they didn't trust that the data was being saved and received. So they would often send their data to the Go Trust, and they wouldn't receive anything in response. The other barrier that I have listed here is because the women weren't sure that their data was saved on the smartphone and that the Go Trust was receiving their information, they were still collecting data on pen and paper in addition to collecting this data digitally. We also found that they had whole organizational systems for their paper-based data collection, and they could go back and easily reference records if they needed to. So they had this whole system in place for their paper-based data collection, and they also weren't sure if their data was being saved and received. So in their opinion, collecting data on paper was necessary, and collecting the same data digitally was double effort. Next slide, please. So this was a very simple nudge that we had developed during the co-design process. In order to help the extension agents to trust that their data was being saved and received, we co-designed a really simple confirmation message. So the women would send their data to the Go Trust on WhatsApp, and now in the current state, they just receive a confirmation message letting them know that their data was saved and received. So this was a very, very simple one that proved to be very effective. We did collect some feedback from the women and whenever we were doing our testing, and we found that over 75% of the women who we spoke to understood that this message meant that their data was indeed saved and received. Next slide, please. So we also co-designed certificates that the women could earn for being digitally enabled extension agents. They could hang the certificates outside their home, and the certificate emphasized that they were helping their communities by being a digitally enabled extension agent. So the idea with the certificate wasn't necessarily to shift the women away from their paper-based data collection models. We know from our research that they find this very important and they find it necessary. Really what we are trying to do is provide a little extra incentive for the women to encourage them to conduct this same data collection digitally, making the double effort worth their while. So whenever we tested this, we found that we gathered feedback on it. We found that most women said that they would like the opportunity to earn it. And we also found that the women who had the opportunity to earn the certificate were more likely to use their smartphones in the fields for their job. Next slide, please. This next example that I'm going to provide is a research that we conducted to redesign and optimize advisory. So we partnered with the Excellence in Agronomy on the Academo Toolkit for smallholder cassava farmers in Nigeria. We were interested in redesigning some of the printed materials. They offer materials to smallholder cassava farmers, extension agents and lead farmers that provide detailed step-by-step instructions on everything from planting to harvest. So we were trying to look for ways to optimize these guides, and we conducted interviews with extension agents and lead farmers. And we found that the guide contained what we call hassle factors, which are really minor inconveniences that have disproportionately large impacts on behavior. So the guides contained so much information, and it took a long time for the farmers to read. We also found that the guides actually made the extension agents and lead farmers do quite a bit of math. We also found that one of the interesting things that we found was that the guides didn't necessarily incorporate or acknowledge traditional farming practices. When we spoke to extension agents and lead farmers, we found that they held on to their traditional farming practices really deeply. And whenever they were kind of confused by the guides or couldn't make sense of the guides, they would often default to their traditional farming practices. Next slide, please. So through the co-design workshops, we explored different ways to make the guides a little more illustrative, removing a lot of the words and replacing them with images. The idea here was that the extension agents and the lead farmers could glance at them really quickly and not spend too much time with the guides and know exactly how to proceed. So we did test these in the field, and we found that on average, they did improve comprehension, but unfortunately the results weren't statistically significant. There's still a little more iteration that needs to be done with the guides. Next slide, please. We also co-designed a series of messages that acknowledge the traditional farming practices of the lead extension agents and the lead farmers and extension agents, sorry. So what the idea behind these messages was that they would provide reminders for the extension agents and lead farmers so that they wouldn't default on their traditional farming practices whenever, just almost like a reminder message. So the one I have here on the slide is, it says that weather patterns are changing, so farming patterns should ideally change too. And the idea here was that we would acknowledge their traditional farming practices, wouldn't necessarily ignore them, but then try to convince them in subtle ways to shift from these traditional farming practices from time to time. Next slide, please. So I'm going to, next slide. I'm going to spend the last 2 minutes here just recapping some of the lessons that we learned from the 3 years of this grant. So it's no secret, and I won't deny the fact that large-scale structural transformations are needed in order to encourage the widespread adoption of digital services for smallholder farmers. There are huge changes that need to be made that are very expensive and will take a long time to change. And the fact of the matter is that no single provider or institution can make these changes alone. But in the meantime, there are relatively small, inexpensive nudges and design tweaks that can make that can help encourage adoption among smallholder farmers of these digital services by removing key barriers. Now, we can probably go about guessing what these barriers are or what these solutions might be, and we might not be totally inaccurate. But the fact of the matter is that I'm willing to bet most of us here are not smallholder farmers from rural or low-income backgrounds. And there's only so much that we can really understand about the context the farmers are operating within without operating within it ourselves. So for this reason, it's really important to put smallholder farmers and extension agents and whoever it is that you're aiming to use your digital service at the center of the research. Just to recap the process that we followed under the digital grant, we started each of our projects by speaking to our different target audiences, conducting interviews with them so they could tell us what the barriers are. And then we took this information into co-design workshops where, again, they told us what the solutions are. So this process is very difficult, I'm not gonna lie. To do it well, it really requires you to check your own assumptions and biases and to do your best to put them aside. It's also very important to be very iterative. You may think you have a really good idea, and a really good idea comes out of the co-design workshop, but when you test it, it might fail in the field, as we saw through some of the examples I provided. So it's important to, of course, test, iterate, and redesign. Next slide, please. So again, I was a bit time constrained. You couldn't really go in depth on some of the findings from our research, but I do have a QR code here that leads you to our microsite. We have tons of fact sheets on some of the different findings that we found. And I also mentioned the toolkit that walks through this process in more detail. And with that, I'll pass it back to Anna. Thank you so much.
Thank you so much, Morgan. That was a really insightful presentation, and I think very good learning opportunity also how we can use human-centered design and behavior research to get a better understanding of farmers and their context. So let's open the floor also to a few questions from the audience. Neda.
Thank you, Morgan. That was a great talk. You know, everything you say makes perfect sense. Some of us are doing this, many of us are not. So what it means is it's a change in the way we have been doing things, even as researchers or others in the sector. Usually to be able to change things like this, it's nice to tell people it'll save you this much time, it'll save you this much money. In the end, the return on investment will be X times more, et cetera. Have you done those kinds of studies? You mentioned RCTs, and I'm wondering if that was an element of your analysis and whether you can throw out some numbers, or is that still a work in progress? Thanks.
Thank you. You want to answer right away or get another one? Okay.
Is it on? Okay, thank you. Excuse me. So unfortunately, that wasn't part of the grant, and we didn't study it explicitly. But there is actually a very comprehensive body of literature on just the cost of nudges in general from other sectors. So while it wasn't necessarily something that we studied under this grant, we were more interested in looking at whether the co-designed interventions overcame the barriers that we were trying to overcome. But there are many studies on the cost of nudges. it depends on like what the nudge is and what you're trying to do. Some nudges are very, very cheap, like SMS nudges. I remember reading a really great literature review on SMS nudges in the agricultural sector, and they're so cost effective. Even if the impact is relatively small, they are a very cost effective intervention. Some nudges are, of course, a little more expensive, but it really just depends on the exact intervention. But I think the point is that these nudges are definitely, no matter what you do, less expensive than a whole structural system redesign, which is kind of what we're trying to do here. We're kind of looking at the system with all of its flaws and looking at ways we can design and test different digital interventions and make them more human-centered and more adoptable by smallholder farmers.
I wasn't so much concerned about the cost of doing it. What I meant was the return on investment is much higher, right? But because presumably by doing this, your adoption is much higher. So it's a cost to benefit, right? Which is both, I think, worth looking at.
For sure, yeah, I would totally agree with you. And unfortunately, we didn't look at it under this study, but could be part 2 if anyone's interested in partnering with me on that.
Yeah, the question right there. Yeah,
Jesus, sorry.
Thank you. My name is Mary, and I'm interested in these AI tools. Most of them are smartphone friendly, but still of a typical farmer. And I'm speaking here in a Kenyan perspective. Most of the indigenous communities who are in the ASALs, most of them are farmers, and we are dependent on the ASAL areas to feed the Kenyan community. So now their phones are they're not smartphones, the old phones, although some don't access any phone. Now, when we are developing these digital tools, did you consider the aspect of USSD? And what is the cost implication? Because remember, this is a farmer, a smallholder farmer, whose income is very minimal because, again, market access is very limited. And these farmers have been taken advantage by the airlines group in that they become the brokers of the produce, brokers of the information, and brokers of everything. Thank you.
Thank you. Yeah, that's a great question. So for this grant specifically, we didn't focus too much on AI. Most of the solutions, or in fact, USSD either, most of the solutions that we were looking at were either SMS, IVR, or WhatsApp. So those were kind of the 3 buckets of technology, I guess, that we looked at here. We did conduct a study, which I unfortunately didn't have time to go into today, looking at ways to optimize IVR advisory. But yeah, all of our solutions were quite, I guess you would call low tech, and looking at ways to get farmers to engage with digital services that were more, it's providing them with information, getting them to act on the information. Those were the sorts of questions that we were looking at. But yeah, surprisingly, USSD did not come up in any of this, and that was mostly driven by the wants and needs of our partners. We really worked closely with the 5 different partners under this grant to make sure that the solutions we were designing and testing were feasible to implement. They were, we wanted to make sure that we got their buy-in. Of course, they aligned with their larger strategies. So yeah, surprisingly, USSD didn't come up, but SMS, IVR, and WhatsApp came up over and over again.
last question. Okay, we can take one last question and then we have to wrap up. Can you hear me okay? Thank you so much for the presentation. My name is Leonie. I work at JPEL Global. We also investigate the behavioral constraints to technology adoption. I'm really curious to hear kind of from the insights that you've gathered what the next step is to kind of share these learnings with policymakers and get them to be taken up also in policy circles. Thanks so much.
Yeah, so the grant is wrapping up. And so the next steps, we actually just recently completed that microsite, so everything's online. We are also trying to organize some dissemination events. Our partner 60 Decibels unfortunately didn't even have any time to get into their work today, but they've done a lot of really great work looking at digital adoption and penetration at the population level. They've been organizing some workshops for policymakers and key stakeholders. I think Boniface maybe have been in some of those. having more targeted conversations around digital service adoption with policymakers. But right now, the plan is to continue organizing some of these events in the different countries where we're working. We have the microsite up. And then, of course, presenting at events like this is really useful for making sure that our findings are disseminated and, of course, are used by other researchers and practitioners.
Thank you. So Boniface asked me to give a comment also to one of the questions before we close. So,
Yeah, I think I'll be very brief. I think the lady asked about farmers are illiterate in rural areas, USSD and all this, and how can they use AI? I want to just help us understand that AI is bringing a lot of solutions that will address that category of farmers. We have things like voice blast. We have things like LLML, language translation. So AI is going to enable these farmers to get the information in local languages, and also using technology like a voice blast, where that text can be converted into a voice. So the farmer just listen with a voice blast using the same feature phone. So let's not demonize AI. It has a lot of good things that will address those challenges that cannot be addressed now. That's what I wanted to say.
thank you. Thank you, Boniface, for this last comment. So I think we would have probably many more questions to continue this discussion. I'm really happy we were able to open this session today with the two keynotes, Morgan and Boniface. Two different perspectives on digital transformation of the food system, but I think the key messages I took away are very clear. I mean, put the people at the center of the process, really listen, empathize, understand, contextualize, and iterate. So I think that are very important messages, and thank you very much. Another applause for Boniface and Morgan.
Yeah, so now, thank you again to Boniface and Morgan. And Boniface, now I understand why they call you the father of the digital agriculture. Sorry? The godfather. Sorry, the godfather of the digital agriculture. The grandfather. Godfather. Oh my God, that's like even higher, right? So thank you so much for also walking us through how to turn data into something actionable. Actionable information and all that takes to get it done, and also Morgan for sharing with us all the iterations that are needed in order to guarantee better adoption of our technologies. And I think that, as Anna said, in your words, Boniface, like how important is to understand the context, and in your words, like how important is to bring the user at the center of the innovation. So that was something that was highlighted also for Anna, and Anna, fortunately, is one of our experts on human-centered design across the organization. So now let's move to the next session, which is about digital innovations for resilient farming.
Right. Before going there, I have a quick intervention to make. So I don't know if any of you were here yesterday. And actually, how many of you are from university or schools or in professional and education career? Okay, so there are some. So yeah, a lot of people, especially from college and university students, came to us yesterday after we finished the AI session. How we get started, where to start, and whom we should contact to really learn about this opportunity. So I thought I was going to give a quick intervention today to introduce young data scientists we have been working together at Cindy, and I will let Nelson to introduce himself and introduce a little bit about the Cindy platform we have been collaborating together.
Perfect. Morning, everyone. Hopefully you can hear me. As Jao introduced me, my name is Nelson, and we've been working together since 2023. And I guess I'm not a university student, but I definitely am young enough to probably know my way around the landscape. And so, as Jao was mentioned, we met through Zindi, and what Zindi is, maybe if someone here is familiar with the platform or has come across it, probably not. I'm not sure if it's on the screen. So my journey is an interesting one. I am from Tanzania. I went to the University of Dar, my background is in statistics, and I became interested with data science in general back in 2019, early 2019, all the way through 2020. And I did a few online programs, and following that, I was curious to just figure out how to dip my toe into the water and just get started with everything. And so, fortunately, I'm not old, I'm not young enough to be Gen Z, but I'm also not too old to be millennial. So I know my way around the internet. And I went around and got to know some of these platforms that offer not only open learning, but also open participation in like projects, like real world problems and solving them through data science. And there are a few, one of which is Kaggle. Probably that's more familiar, like a lot more people are familiar with Kaggle, where you have these businesses that host their problems on the platform, and you have participants engaging with it in forms of competitions. But the one I went to is known as Zindu. Not sure if it's on the screen yet. It's not, but if in case anyone is curious or anyone wants to know more about it, then for sure it'll be an interesting conversation to have. And yeah, basically it's just a platform for data science where you have real world problems and you can engage with them, and that's how I make Yao.
Okay, great, thanks. And Nelson will be sitting here. So any of your kind of avid data scientists or want to learn more about data scientists and digital innovation challenges, yeah, please find Nelson and talk about it. For technical issue, we couldn't show Cindy on the screen, but CGIAR ran 8 Cindy challenges so far, and a lot of those challenges, most of the challenges develop very interesting and useful machine learning models that are being used in the field. So yeah, please find more about it, more about Cindy talking to Nelson. Okay, great.
Okay, so thank you, Nelson. And also, one there. Sorry? I didn't. The what?
Yes, it's here.
You cannot hear us. Okay, good. So thank you, Nelson. Thank you. It also highlights something that I was telling when I was introducing this session today, the importance of youth. But I'm always surprised in Africa how we find like such a talented young people working on data science and on all these topics. So thank you, Nelson. And now we can move to the next session, which is innovations from resilient farming. We're going to hear from our speakers on topics including artificial intelligence, plant disease diagnosis, real-time digital tools for smart farming, and digital twins for water management. So I will start with you, Trinka. Okay.
Good morning. Can I please have the presentation? My name is Srikant. I have come from Hyderabad, India. I lead an innovation sub there that was also started by Ram Dulipala, who is here almost 8-9 years ago. And I'm sorry that Sam is not joining me here. Are you there, Sam? Because he was not well. So I will be speaking for this 10 minutes. Next slide, please. It's an AI-based plant disease diagnosis for last mile delivery. So I'll be talking about an application that has been very useful in most part of the world, developing world. So can we change the slide? We're in digital AI time. Yeah, I can keep on talking. So this is a German startup. We started in Hanover, and they had a proof of concept by using AI algorithm to decipher nutrient deficiencies in tomato. They were soil scientists. So when they had a proof of concept and they were scouting, they came to Mali and they suggested, they went to ICRISAT office in Mali, and then they were sent to the main campus, Hyderabad, Patancheru. That's where the relationships kick-started in late 2015, that is early 2016. And we started working on this application, Plantix. So if you can spot the difference between the two images over there, we can make the machine do the same. deep neural networks. That's what the whole algorithm was based on. The CNN. Next one. Yes. So the image processing started way back in 2016 with the POC, but then we had the challenge of making the training data sets for a lot more pest diseases and deficiencies symptoms. So if you want AI to work well, please can you also, because I think there is an animation there, there is some data over there. Yeah. So it's now reached more than 45 million users around the world, a monthly average of more than 1 million users all over the world. So there's not a country probably which has not got a user from using Plantix. It is the largest application in the Google Play Store, and it's in 18 global languages. Most difficult part was translating it from English into a palatable form in the local language. No wonder on December 10th last year, we launched it in Swahili, and we saw huge rise in the numbers. See, that's where AI can be wonderful, but the scientific content need to be given in a palatable form. So that's where things can go very wrong with many other startups and products that we have seen and witnessed in the Innovations Hub. So this is some of the things that also helped us was the public-private partnerships. I think that is critical. You can have the best of the idea, best of the product, but we see graveyard of projects actually going down because there is no relationship with the governments, because the other stakeholders are equally important if you want to take something forward. So that's where we see that the success of this application has been mainly because of the participation of the governments, NGOs, and the private players were able to make a dent in this area, reaching out to the farmers. So it's a consortium effort. Next one. You have seen in the video, it's very easy, very simple. The user interface is so simple and so demystifying for any user. Even a semi-literate farmer should be able to use the application. So it all started with a lot of focus group discussions with farmer groups, including women. This is led by a CEO who is a lady. So that was where I saw the importance of, in the user interface and the user experience, the involvement of women farmers also. So if you see this global picture, you'll be seeing the dots are so concentrated in India. No wonder they have moved to India. Now it's an Indian startup working in India. So I'm so happy that Africa, and especially the East Africa and Kenya. So next slide. Okay, this is what the reason the reason it was they came to India was about 75% of the users are now based in India. Smallholder farmers, huge numbers. There are many other features within the application. Well, it started with a unique selling point of disease detection. Farmers were interested in many other things because we were a dryland and semi-arid tropics people. We approached farmers in the drier regions. They sought weather. They needed weather information. So any product that is made, it should not be stopped with the idea itself. It should be willing to grow, expand, and the sprints have to be faster based on the feedback that we receive from the farmers. So we included the weather into it. Then we also realized this app was not functional for many other crops. So a community social media type of tab was also included, so that we were surprised. Every day there are about 20,000 to 25,000 messages shared in 16 different languages, 18 different languages. And most of the people who were using the application were able to solve. Some students, you name it. People jump out to answer queries from their fellow farmers in the community. So that is itself a huge plus point for this application. Like, you can ask a question. If you're not satisfied with the answer thrown by the application, you can always ask, is there some other way of addressing my problem? That gets answered within 6 hours, the average time to answer any query within the application. Then slowly we went on to see that not all diseases, when they appear, you can solve them. You can do with good agriculture practices much before and avoid the problem. So the crop advisory, which is very specific to the user farmer, that is targeted, if you give the sowing time, it will automate and give push notifications of what to do in this management of the crop. So that's very unique and that's very helpful. Almost during the season, crop season, we see about 500,000 of farmers using this very feature. Last but not least, the partner Dukan that you see, while we try to give the best of the advisories to the farmers, but they rely on the traders and the marketplace. And when they go there, they still, the vulnerability of farmer enables the traders to make most of that. Like even that, they know what they have to use to control the damage, but ultimately they spend more. That leads to unjustified and products being sold, environmental damages, etc. Next one. So very simple user interface, as I said before, very simple with icons and those images, so that anyone with semi-literate, because we did this in India, so I'm very sure it works in places with semi-literacy too. Next one. And local language, Swahili, who speak and can read. This is what happened. The local language, that triggered more users also. And we believe that anything we do, the local contextual content and the language are key for success. Next one. Users in Kenya, you can see what happened just in the last month of December 2024. Those are the numbers. And here is the team. And we also are working with Carlo. So this is the partnership. So I believe that there is a lot more to be done in Africa, and we are willing to do that, especially with the African strategy that was launched a couple of days ago by ICRISAT. So things will be, we are hoping that we will penetrate more areas in Africa. Next one. Yes, there may be questions for some of the researchers here. Please click. Yeah, so every sample from the field that we collected is a small video, which is actually evaluated by an expert, like a pathologist, plant pathologist, or an entomologist, or a soil scientist, or a physiologist, so that we could see with around 9,500 samples. This is a very good performance. It's not statistical significance, but here we have to see how the app is performing in the field. So next one. The data that comes. Here is the researcher's real treasure. Each image comes with timestamp and the location stamp. We never had this before. We can use that. We are already into modeling so that we can actually predict because of weather data and soil data that is available. So for rice, we are trying this, and very soon it will come up. Next slide. So we know exactly in which location, where is the problem, so that the extension services can be focused over there. That's the key. And this is real-time availability. For example, I'll show you about groundnut, the number of diseases. This is last 2-year data. We had around 500,000 users images. These are all images. So mind you, I'm talking about 120 million image data sets that are already there. It is the largest in the world. Next one. So within that, foot and collar rot. This was like, for us, we can actually see which is the most prevalent disease in a particular location, so that this type of data was not there available earlier. But because of this AI, we can actually get good quality data, and doing modeling and then going for this future prediction is more possible now. At least a reasonable good quality prediction of disease and pest. Next one, please. Thank you. Cheers. Anyone wants to ask one question aloud? Yes, ma'am.
Thank you for your presentation. I'm a plant pathologist, lecturer at Technical University of Kenya. So I just want to know, like, how can this app be able to differentiate between symptoms that you see visually that are actually caused by abiotic conditions and biotic conditions?
Thank you. Wonderful question. Because unless a plant pathologist puts it under a microscope, you cannot say that. For most of the symptoms that we see visible for nutrient deficiencies match with pathogens initially. So the difficulty here is the training data sets have to be made with absolute knowledge and classifying them. So, okay. So Yeah, we collected most of the nutrient deficiency symptoms from soil scientists' experiments in research centers. When they know about nitrogen, phosphorus, potassium, we are 100% sure that this is a deficiency of nitrogen. So not everywhere we are 100% sure, but most of the cases, you will also have multiple diseases at the same time. Example, in a panicle, you can have a fungal rot and a bacterial disease, or even a viral or something else on it. So there is a possibility where we are now breaking down that if in the image you have multiple diseases or symptoms available, then it will give a percentage of it. We are not saying that this is 100% sure, but more than 90%, then the advisory goes. Otherwise, the app says, take another image, give us one more chance. Yep, that should do. It's not perfect, but 90% reasonable prediction is better than going to a trader and giving them a sample and taking and using the product. So this is like a farmer's empowerment tool. That's what we believe. Yep.
Okay, so is Alok from IMI here yet? Okay, good.
Good. And thank you, Sriram. Thank you. You know, like many of us consider you like the father of plantics, one of the first approaches in order to detect pest and diseases. So we kind of have the generational line here, right? The grandfather, the father you of plantics, and probably the youth with Nelson will be the next generation. Okay. Thank you. So we've been told that we need to use this mic. Okay. Okay.
Can use this. Moving around is always good, but it's okay. I'll use this because that's all right. So I think the earlier speaker has really given a wonderful talk about this thing. So, and this particular topic on which I'm going to be talking about is basically how best we have been using this smart farming platform called GeoGovia in Sri Lanka, and I'm standing in for my colleague who could not make it. So I'm not part of this study, but I'm remotely involved. So I'll try and do the justice to this kind of a presentation. And this is also, I feel very happy that luckily the Secretary of Agriculture, Irrigation and Livestock, Sri Lanka is here, with whom we are working. So maybe Mr. Vikram Singh, if you can also join here, maybe towards the end, I'll just give him 1 minute to see how best they are making use of it. So let it come it from horse's mouth. All right. So next, please. So in this, what basically we are trying to do, because we know that whatever are the challenges with the farmers, and particularly we know also the post-COVID and also the kind of the fertilizer ban in Sri Lanka, and then many repercussions after that, and of course the extreme weather events. And this particular thing, we are more focused on the extreme weather events, droughts and the floods. That's behind our major intention. And there we have been really looking into that, how best we can really get over that and try and minimize the losses to the farmers. Next. And in that perspective, next, please. Yeah. Here, this is what the GeoGovia platform does. First of all, let me tell what is GeoGovia. GeoGovia means, geo means we know it's a geographical space, and Govia is a farmer. So how best we are trying to put this, all this data analytics and satellite data for the use of the farmers. And so it's basically a data-driven smart agriculture platform which facilitates access to agriculture expertise, advices, and assisting the farmers and the community for optimizing the cropping systems and the cropping decisions and managing resources more effectively. So that's the kind of the idea behind this thing. And here, as I said, we are working very, very closely with the government. Next, please. And the way we started working on was this, there is the agrarian department there. We have been working with them. Yes, can you change to the next, or you can give me control? Yeah, here, these are the various modules of this GeoGovia when we are trying to be really looking into that. And those modules, I'm now going to get into, they start with registering the farmers in the farm registry, land records, and the type of the crops. So we are using the blockchain in that. And it is just not ending there. It is also for cash grants and compensation and the fertilizer subsidies and other things that the government gives them. So it's kind of a platform. It is just not simply a weather advisory or the agro advisory, but also linking and integrating many other things which are really useful. And so there are bundle of apps and bundle of technological interventions which really go into that beyond what we do regular simple weather and agro advisory services. And so these are the kind of the total paddy lands, 1.82 million. I'm not going to read out those numbers. So next. So in the next slide, what you will see is the layout of this complete platform. That this is, as I said, we are trying to be more inclusive in terms of the agriculture development. And here, if you see, you have a dashboard where you can have many users and options, starting with the farmer registration and then going to various activities. And we have also linked it with another app which is called Cultivate X. So here, as you see, in this case, the last slide, the last portion what it shows is that we are zooming in for a particular district or a particular location, how that thing is. So all these are the kind of numbers which we are getting when you are trying to see the province-wise, the district-wise, and the various sub-district level at the village level information that is really coming in from there. So next, please. And in the next slide, you will see that how then we are trying to be integrating that with the crop calendar and the crop advisories over here. And this is the way that we are doing it more dynamically. Like here, if you see in the pull down menu, it says what is the crop, it's black ground. And then it's in the dry zone because, you know, the entire Sri Lanka is divided in various weather zones. So this is for that. And then what is the crop agriculture practices, crop variety, another. So like that, these are the kind of the information which automatically goes into the system. And then you kind of send them via mobile apps, the advisories. And as the previous speaker was talking, in the local language. English, Tamil, and Sinhalese, because these are three common languages which they used over there. And so accordingly, based on that, weather advisories, I can't go into detail, which are there, that they adjust and manage their crops and schedule irrigation and many other aspects. Next, please. So this is just a tool that where I said that we are also trying to track the plot level information as the in a real time basis. And how in a real time basis, and whether it's a individual farmers, tenant farmer, and what kind of activities are being done. And so those are the kind of things which are captured in a near real time basis on every season basis. Next. This one is a particular feature which is basically not for the users, means the farming community. This is to help the government. And Mr. Vikram Singh is there. Maybe I'll give him time to speak for a minute about that. This is how this, only the government has got access to that in trying to see how they can manage the cash grants, and also they can do M&E and also upload the validated and experimental data which they are also collecting in the field. So next. This is the finally, as I said, besides those giving those advisories and this thing, they are also looking into giving financial assistance. And using this app, the government has really saved about $1.6 billion. And so this has become really a very effective tracking tool wherein you can really track the cash transfers and how the best the farmers are getting benefited. So this is something which I think you will appreciate. Next, please. Here, this is just to kind of not an evaluation, but just some kind of our experiential learning from there, where based on the data which we have for last 1 or 2 years, that just an example that how you can see the in terms of the outcome, the reduction in the fertilizers and inorganic pesticides, and at the same time increase in the crop yield and the overall gross return to the farmers. So this is something, of course, you can see there the blue dots are conventional, and how over a period of time the farmers are switching over to this kind of using this kind of an app. So the next one. And so this one is again what we are trying to be looking into, bundling. Now here when we are doing bundling with the weather index, also an aggregated model, this is something that we started in India, where I was also involved. We did how for rice, So for example, you know that depth of duration, depth of inundation, and the frequency. With that, if you can do the yield damage assessment curve, and so which we have now used there to do the weather index insurance, and this is something also we are now replicating over there. Now my last slide is that, no, just go back. This is the one where, as I said, because this we did it under the CGIAR Climate Action Program we have been working, and together with the Japan assistant from MAP, and now we are going to be working to some other areas, some other countries, which are going to be working with us as a part of the CASP Climate Action Science Program. So with this, thank you very much. And before I leave the podium, I'll request Mr. Vikrama Singhe, please come and say how you think it is really making any use to you or not. So what do you think? So I hope I haven't taken all my time. So.
Right. Thank you very much. Actually, he explained about this app, because this app actually prepared only on our necessity basis. Because you know that the paddy farms, there's no any boundaries. So we had the big problem that the farmers declare their farmland is in different ways. So on that time, the government provides a fertilizer on a very subsidiary rate, about the less than about the 1/4 of the market price. So the farmers declare, if they are, for example, if their land is 1 acre, they declare that it's as a 1.5 acre, because we have to, because they can get the more fertilizer in subsidized price. In addition to that, the village level officers also declare some wrong information to the agriculture department about their land extents. Finally, what happened is, at the end of the season, we have issued the large number of fertilizer, and we are calculating our crop on the basis of that fertilizer. But really, there's no results like such a thing. We are doing all our national statistics about our crop and everything based on this fertilizer. Then the governments want to get this type of app, and then our village level officers measure these paddy lands and identify the real extent. And GeoGovia app is applied for this, and now we know real extent of the farmland, and we know who is the farmer doing this cultivation, and every time we are updating this. Before the starting the season, our village level officers go in there and asking who is the farmer of this time, because sometimes some fields farmer change time to time. Owner will give for growing to another people, but we are updating it that we are issuing the real stocks of the fertilizer. Actually, now we are not giving the fertilizer, now we are giving the money for this. So at the starting point of the crop, we issue the money for their bank accounts directly. So now we know that real extent as well as the person who are growing. In addition to that, we are collecting the data about the paddy varieties. There are so many varieties, because people are consuming different areas, consuming different varieties. Now at the end of the season, we know that this much of areas has grown this variety and this variety and this variety. Then we know that is that sufficient with our country's requirement. The one recent example, actually this is a very flexible app. Very recently, you know that in the last 2 months or 1 month before, there was a big rain and it's damaged to finish. All right, it's damaged our crops, and government asked from me, what is the real crop now? Then I asked to the managers of this
geophobia, and they went to the field to field and calculate the real crop and enter to the system. And every week I get the real information, and then we decide we could calculate the agriculture department estimate and the real crop. Because this is a very practical, we can expand this for another fields also. Thank you.
Thank you, Mr. Vikas.
So thank you, our colleague from Aleph, and also you for sharing your experience. And at the end, we will have some time for questions. So I guess that we can ask you questions to you both, actually. So now we can move to the next presentation to Fulco, that is going to share with us the experience with the digital twin for water management. Actually, it was supposed to be given by Angie, which is a colleague of ours.
Yeah. So Angie was too busy and had a lot of other traveling. But yeah, this is definitely Angie's work and her team. We've done, I think, a great job in developing this digital twin. So next slide. So we've developed this digital twin for the Limpopo Basin, which is a transboundary basin in Southern Africa. And we looked at this basin for a number of reasons. There was definitely a need for an improvement of the kind of transboundary water management. And they were looking for methods and tools to do on that. So with the Limpopo Basin Authority, we thought, okay, let's work on this and see if we can develop something which is both kind of scientifically interesting in terms of developing a digital twins using new AI technologies, but at the same time something which actually is relevant for water, land, and food management. So next slide, please. So if we look at the kind of problems that there are transboundary, so there's definitely a water quality issue. There's a declining, availability of water resources, or at least an increased competition. There's increased variability. It's a region in the world that is drying due to climate change. There's a loss of biodiversity, land degradation, some sedimentation, and low resilience to kind of extreme climate events. Next slide, please. So this is kind of the layout of the digital twin. So it's a bit of a kind of complicated slide, but maybe look at the kind of white numbers that you see. So the digital twin is built up from different components. So we've integrated different. So in the middle is a kind of hydrological model SWOT combined with a kind of 3D visualization that we were doing. And the other components are long-term and seasonal water availability forecast using seasonal forecasts. We looked at water quality monitoring using FISCRAT. So we involved citizen science to look at water quality. We used fishes, we monitored the fishes, and based on their behavior, we looked at water quality. There was an e-flow, which is environmental flow framework using the crop flow. So one of the things was to protect biodiversity. We said, okay, we defined a minimum flow, what we call environmental flow. So first, the water goes to the environment. Any additional water can be used by other users, municipality, irrigation, etc. And then finally, we looked at an irrigated area monitoring system. So using satellite data and AI, we had a sort of real-time monitoring of where and how much irrigation was going on. So we could, in that sense, manage the water better. Next slide, please. Oh, yeah. So this is one of the water availability forecasts that we were doing. So there's a lot of seasonal variability, a lot of interannual variability in this region. It's highly affected by El Nino, tends to be drought during the El Nino years, tends to be wet during La Nina. So we can use those systems to look at longer term water availability forecasts. And as a result of that, by knowing further in advance whether we have more water or higher chances of floods, or whether we have droughts forecast. So already when we forecasted less water availability, we can intervene earlier by trying to limit water use by different users. Next slide, please. So another one is looking at the drought status for the basin. As I said, it's heavily affected by climate variability. There's a lot of droughts in this region. And so we try to both monitor and predict the droughts. So For example, over 2023 was a relatively wet year, so we could predict well in advance that there was sufficient water availability. 2024, during the El Nino, we could clearly monitor, and there's a picture from that where it's red, that's clear droughts. So we saw the droughts coming well in advance, and could, as a result of that, the basin could actually intervene sooner than you would have without this system. Next slide, please. So irrigation mapping. So to get a better handle of how much water is actually used. So that's also clear and unclear in the basin. Where does the water actually go to? Who's using what? How much is used? So there's a lot of irrigation going on in the basin. There's not that many kind of big systems, but there's a lot of smaller systems. So using satellite data, which we also in the end did some ground truthing with some students, we looked at actually the status of the irrigated area. And by using the kind of satellites as well, we didn't only have a map of irrigated land or land potential for irrigating, but we could in real time actually following how much irrigation was going on, and based on that also do an estimate of how much water is actually extracted from the river, which could have impact in transboundary management, etc. Next slide, please. So visualization is also very important. So that's one of the key things that you can do with this digital twins is making different visualizations. And these can be visualizations of floods, of land use. You can also make visualizations of future scenarios to say, hey, what if we do this? You can do some what ifs. If I build a dam here, what happens? If I increase irrigated area, what happens? And also by being able to visualize that, we make it more attractive for the stakeholders. And as a result of that, we hope that it will generate more actions. And what we hope is that we almost doing kind of workshops and say, hey, what are some future interventions you'd like to do? What will be the impact on water and other systems through that? Next slide, please. So this is more the technical aspect of the digital twin. I don't want to get into the details of this. I mean, this is where, of course, the digital innovation comes in, where we're looking at the information and data flow between the different systems that we are developing, from more existing pathways to kind of new pathways, using apps also to look at citizen science, giving us information about water quality, etc. Next slide, please. So what we're working at the moment is okay, if you have this system, and how can people use it, and especially how can people use it who are technologically not well skilled. So that's where we're developing what we call a water co-pilot. So co-pilot, maybe some of you have used that. That's the Microsoft kind of AI tool. We want to make something that's specifically linked to water, and as a sort of making a kind of chatbot or an AI system that helps you to guide through the systems. Yeah. So instead of only having a kind of frequently asked questions section, what some of these tools have, or people will get stuck in certain situations, can't download the data, you need to be highly technical. With this use of this AI tool and the co-pilot, we hope that we can make it much easier for a lot of people to use. So we're not there yet. I mean, it doesn't always give the answer that we would like them to give. So it works still better with people who know what kind of question to ask, which is with a lot of AI tools. So we hope to make it smart, and of course, by increased use, those tools can also help to become better. So this is one of the tools that we want to add to the system. Next one, please. Let's get on. Let's skip this one for time. Yeah, go to the next one. Yeah. So I mean, I talk a lot about technology, about data, maybe a little bit about the beginning, but the people who use the system, who give input to systems, are also very important. So we try to have also hands-on activities so that actually the people from the Limpopo Basin, the people who make the decisions on the transboundary water management or about future investment, can really use the tool and can do something about it, and that the tool also does something that they require. Next slide. All right, well, this is kind of the different phases that we had, or that Angel's gone through. I think she's done great work over the last year. We started about over a year ago with developing this, and I think we've made some great stats. So these are the different phases that we've gone from design thinking to how can we develop affordable infrastructure, scientific projects, what we call kind of democratizing access to knowledge. So how can we use AI to get more access to the system? So we've seen that a lot of technologies have limited access. So can we also actually use this technology to increase access? And what we're working at the moment, I mean, capacity building in this sense is very important. Learning the people how to use the system, gaining trust in the system, so people, I want to use it to make decisions on. Next slide, please. That's the. Let's skip this for time. So this is where we are tomorrow. That's right. That's right. So these are the different components that we have been developing as well. I haven't talked much about the citizen science, which I think is also a cool element. So we use them for different ways. They take water samples and then they look at the invertebrates. And from the diversity of the invertebrates, we can make an indicator of the water quality. So if a lot of the citizen science gave us samples where we think, hey, the water quality is deteriorating, we can now much sooner kind of diagnose that with the more traditional things where we need to take water samples or waiting for the fish to die. Another way that we're doing it is labeling some fish. So we label actually, we give the fish a sensor so we can track the fishes, and based on the fish behavior, we can also get an indication of the water quality. So we'll know on the bad water quality, they tend to change their behavior. And again, we have an early indicator of water quality problems. So we talked about the water co-pilot assistant. There's a whole data portal. We've also used some drone technology, especially to look at the elevation maps that we've been developing. Next slide, please. All right. Well, this is different publications, so I think you can read that. But I really would emphasize there's already a lot of publications on the digital twins, but also on the e-flow monitoring tools, on the droughts that we're working on. At the fish track, there's not a paper yet, but there's some news on that, and we have some papers on the irrigation mapping. Next slide, please. Well, I think thank you. Again, I want to thank Angie and the team and our many sponsors who've done a great job in developing this, and we've pitched this at a lot of other parts in the world as well, and there's a lot of regions which are interested in duplicating this kind of work.
Thank you so much, Fulco. So we still have one more presentation before to take the break. But if there's any question at this point, we would like to take some questions from the audience. Sure, can you use the mic?
Thank you very much for sharing. My name is Michel Onana. I'm from Congo, in a small city called Goma. I would love to ask a question. I found it really interesting to see how data science is helping farmers on the ground and how platforms are working with the government to provide real-time support. As a young person who is not in the study but passionate about this space, I would love to ask, how can young from underserved region like mine actively participate in the real world data science, not as a learner but as a co-creator and change makers?
All right, so if I understand well, so how can people in a more underdeveloped region also benefit from this and be involved in co-creation? The good thing about the system is that we can do a lot with kind of satellite data. So we also have a water accounting team, which can give us a lot of input on water flows, etc., even without having on-the-ground observations. Of course, the more on-the-ground observations we have, the better it is. It's also, I mean, what we need in this case is, what is your problem? Where is your issue to do? Maybe related to that, we are developing also a digital twin for some of the refugee camps in Somalia. So we're doing things already in kind of fragile areas where we can actually develop these kind of tools as well. I mean, the main limitation in the end, I would say, is the funding available to come and work with you. You know, we unfortunately we can't do this for free, but of course we can talk to you and then look at funding together. But we are definitely wanting to expand this world also to regions where there's limited capacity and limited development.
Thank you. This is really interesting. I'm from Vietnam. Could you explain more in detail how the drone technology can serve for modeling of water, etc.? In Vietnam, we are promoting drone technology for different activities in the rice system. But,
So we've used drones for two issues, but the key issues I think we have in this project where we've used this for is for ground truthing of the kind of irrigated map areas that we developed from. So we developed the irrigated map area from satellite. We wanted to do ground truthing on the ground, whether that was actually irrigated or not. So therefore we used a drone to look from the area to do, which is a one-day snapshot, but we could do a little bit more spatially than actually if you go walking around and track weather. So that's the key issue. Another where drones are also great is using, we've done that for digital elevation maps. Those are also, and otherwise kind of detailed land use mapping. So more detail that you can do from satellites, maybe a bit less detail than really working on the ground and picking things, but their drones can also be, you can cover a relatively large area with large detail with drones.
I guess that we can, thank you, Fulco. I guess we can move on to the next presentation, which is
And then I can continue to work. It's always hard to be before the break. Although after the break can also be hard when people tend to fall asleep on the food. Again, I was actually realizing I haven't probably introduced myself. So my name is Fulco Ludwig. I'm the Director of Water Data Science and Digital Innovation at IMI. And actually this work is mainly done by my colleagues. So the first presentation mainly by Angie. This one is done by my other team leader, which is Naga Pelpuri, with his kind of water accounting team. And in this case, we've looked specifically actually at vegetables and how we can stimulate sustainable irrigation in vegetable systems in Africa. Next slide, please. So very, very simply, what we look, I mean, vegetable production is very important to get for the nutrition. It can also be very important for income of small farmers. They're usually more highly valued products than things like rice and maize. So it can be so traditionally most of the vegetables were produced under rain-fed conditions, and that's still happening in most of the cases in Africa. However, since we need to increase vegetable production, and we at the same time also have climate change, which actually makes the weather more variable, there is a need to increase irrigation into vegetable production. Well, at the same time, we know that there's been a lot of unsustainable kind of irrigation and water use around the globe, so we want to avoid that. So we try to develop a tool to stimulate the increase in vegetable production using irrigation. Next slide, please. So if we look globally, I mean, there's not a lot of data on irrigated water use for vegetables. There's a lot of data on the major crops. There's on rice, on wheat, on maize. There's a lot of data on that. A lot of the kind of global studies use only a few number of crops or avoiding vegetables because it's difficult. We did try to make an estimation, and we think that still about 1/3 of the water that we use is actually used for vegetable production. This is around the globe, so this is a global issue. So if we look about how much we use globally for water, for food production, how much water we use. So green water, which comes from rain-fed agriculture, 5,000 cubic kilometers. About 1,000 is for irrigation. If we look at vegetables, we think that there might be up to 333 cubic kilometers per year, which is about 1/3 of the total blue water production. So to give you an image, I don't know if that really helps. That's 133 million Olympic swimming pools. And at the same time, but I think what might actually be more important, this is about 72% of the global demand for domestic use. So it's almost as much as domestic water use, what we use actually to irrigate vegetables. Next slide, please. So at the moment, there's a lot of unsustainable irrigation practices around the world. And I'm showing this because at the moment, actually, there's not that much unsustainable irrigated practices in Africa. But we want to avoid, by increasing the irrigation, that we go into the same way as what we see happening in India, Pakistan, for example. So where you see the pinkish kind of purple, pinkish kind of is a unsustainable groundwater use, which we mainly see in kind of the high plains in the US, the kind of India, Pakistan kind of region, northern China. At the same time, there's also a lot of unsustainable surface water use. So this is basically using surface water beyond what the environment can tolerate, and that's the blue one. So we see again a lot of that in Asia. We see quite a lot of that also in Southern Europe and throughout Southeast Asia. Anyway, so this is what we want to avoid in Africa. So we want to say, okay, we realize there's a lot of potential for irrigation of crops, in this case vegetables. At the same time, we want to avoid that we develop new irrigation systems where it's unsustainable. So next slide, please. Anyway, so this is about the total unsustainable use of water resources. This is a paper from Rose et al., where she looked at different crops. If we look at the fruits and vegetables, that's the one in the box. The left one is 2015, the right one is 2000. So we see after the major crops, maize, wheat, and rice, that fruits and vegetables are the major source for unsustainable groundwater use and surface use. Yes. Okay, so we developed a sustainable framework for vegetable irrigation. That's what we do. So we first wanted to know how much water is actually sustainably available. And we look both at the surface water side. So we use our water accounting data, which gives for about every square kilometer the amount of flow. So we know throughout Africa how much water there's available in the river system. So we have monthly river discharge data, and we have monthly water body maps. So we can also see what we can use for lakes and other kinds of water bodies. On the other hand, we looked at groundwater. So we defined the utilizable groundwater as the groundwater recharge potential minus what is already used in terms of groundwater. In some areas, there's already significant groundwater use, some areas not. So that's again. So if you add the one together, so we have the kind of surface water limits and we have the groundwater limits, that's totally what is sustainably available for irrigation. Next slide. So that's the question then is, so how can we make vegetable irrigation sustainable? We only use the renewable water sources. So only the groundwater that's renewable, and we only use as much as there's recharge. We maintain the water use within the limits of the water availability. So we also take into account the environmental needs of the water, and we want to avoid over abstraction. Okay, so we have developed a sustainable framework. This is what we use as data input. So we have different data sets for different purposes. So we have the precipitation data sets, which we use from satellite data. We have evapotranspiration, also from remote sensing. We then have a distinguishing between blue and green water ET, so the irrigated water and the green water. We look at runoff groundwater recharge. From that, we have the utilizable groundwater potential, and we have the current already irrigated and rainfed maps, so we can actually look at the current water use. Next slide, please. So this is a kind of modeling system. I think it's too hard to read that from the system, but actually this looks at the flow of information from the different systems. So we actually get to areas where we can sustainably do vegetable irrigation and where not. So based on that, we make this tool. And this is an example for Ethiopia, where we developed a sustainability framework for the vegetable irrigation. So one of the key components is what I've explained to you in terms, is the water sustainably available? But we also had a few other indicators to actually see whether it's suitable or not. So in this map, where it's brownish, there it's not suitable. So these are the dry parts of the country. Where it's green, it is more suitable. And what you see is basically we have different indicators, and when it's green, then it's positive, and when it's red, then it's negative. And so there's climate stability in there, there's risk, there's groundwater suitability, the surface water suitability, but we also looked at terrain. If it's high mountains, it's usually harder to do. We looked at the soil types, and we looked at some socio-economic suitability. Yeah, if you're closer to a road, if you're closer to a city, there's probably higher demands. There's probably higher prices of the vegetable, which makes it more interesting to do the irrigation. So this is a tool that a government or somebody who wants to develop irrigation can use, and it's basically a first check of, hey, where should I start if I want to increase irrigation? Next slide, please. Now, another tool that we developed is different vegetables, of course, need different amounts of water. And what you can see here is the first bigger one is what you get at the moment is, okay, this is where you can grow crops which need 400 millimeters or less. So then we have a lot of them. The green means you can do it with rainfall. So if you have a vegetable crop which only needs 400 millimeters, you can use that throughout the country. This is Zambia. And then you look at 800 up to 1200, and where it turns yellow, it means that you need additional irrigation, and that irrigation water is also actually available. So this gives a first kind of shot of which vegetable you would grow where, mainly based on the water needs. So of course there are different vegetables. I also have different kind of ranges of temperatures where they can grow, humidity issues, but this looks at the water demands of the different vegetables. Next slide, please. So this is the last slide. So I'm not sure if the movie's working, but this would give an example of the actual vegetable irrigation toolkit. So we developed a toolkit. At the moment, we've developed it for 2 countries, but we want to develop it for more countries where you can actually click at what kind of vegetable you want, what kind of areas, etc., and it gives you suitability maps throughout the country. Thank you. Okay. All right, so if you have more questions, especially Naga Corporia, Mokta and Bailey, who've actually developed this, you can contact.
Well, I mean, we can still take 1 or 2 questions if you have. Do we have any questions from there? Please go ahead.
Thank you for the presentation. My name is Mohammed from the University of Nairobi. I'm a student of computer science. So my question is, I don't know if you have mentioned in the presentation, how is your sustainability framework helpful in arid or semi-arid areas where the amount of rainfall is very, very limited, or sometimes they don't even get rain for many years? How is your sustainability framework provide solutions for such areas?
I can be very blunt and say it's probably not sustainable when there's very little rainfall. In that sense, it's helpful. It's saying that it's not possible there. So I think this gets to the question, especially if you haven't had rain for a number of years, the potential for agriculture, I think, are very small, unless you have a groundwater or a surface water source where you can do it. That's basically what they do around the Nile. There might be groundwater resource that you can use. But if the rainfall is very low, your recharge is probably also very low. So your sustainable groundwater use is also very limited. So I think in that sense, for the real, I mean, you see this in the Zambia picture as well. I mean, where it gets very dry, there's not a lot of areas where it's sustainable. So the only thing where it helps is actually saying this is not the sustainable areas where you can actually expand it. So it's not a rainmaker. I'm sorry. Yeah. Other questions? Time for a break.
Thank you, Pulko. So now let's take a break. We have a break of 20 minutes, and so we'll be back in 20 minutes. Okay. Sorry. Oh yeah, there's tea and coffee outside, and some snacks, right? No. Okay.
Okay, so please come back in 20 minutes and we will continue after that. So online participant and the presenter of the next sessions, we will be shifting timeline by 20 minutes because there has been a lot of intense presentation in the morning, so we will have some quick break. Thanks for your understanding. Thanks.
Good afternoon, Java.
Yeah, hi Marty. So yeah, 2 more minutes.
Okay.
Yeah, okay, we are almost done. Okay, so people on the break. So let's get started again. Yeah, thanks for coming in back. We will start in 2 minutes.
Okay, thank you, Joe.
I'm sorry. I'm sorry, I was muted. Murali, can you try sharing your screen? We do have your copy of your presentation as a backup, but I think yeah, it might be better if you can share from your side. Yeah, okay, it's coming. There you go. Okay, great. So let's get started. People are still coming back from the break, but I think we can get started. There are some audience members online also waiting, so thanks for your patience. So yeah, I'd like to introduce Murali Kumar. So Murali Krishna Kumar, who is a geospatial scientist at ICRISAT. And I have known Murali for like more than 15 years, and he's one of the most productive researcher. If you have ever used any cropland data set, in GIS, working on remote sensing and trying to find where different crops are grown in especially South Asia, you must probably have run across already or already using Murali's data. Yeah, today he's going to show us new research results on crop area and crop yield estimation using remote sensing data, crop models, and machine learning algorithms. So we are very much looking forward to hearing from Murali what's new and what's next. Murali, over to you. Thanks for joining us today.
Thank you, Javo, and thank you all. Good afternoon, all of you. This is my presentation, crop area and crop yield estimation. In India or many places, crop area and yield estimation is very crucial, especially for the governments. They want to implement any kind of, welfare schemes, pricing, procurement, storage, transportation, and everything. It is really very crucial. And today I'm going to talk about in-season crop monitoring and the crop yield estimation using crop models and semi-physical model, of course, machine learning as well. But there are some limitations also there.
which I am going to talk. Yes, first of all, I'll give a background about this one, why we are doing crop area and crop yield. First thing is, improving resource allocation. For example, granular, accurate, and timely information is very much useful for the government to implement the schemes and other purposes to support the farmers. And also understanding agriculture pattern. For example, for particular location, what crop and when it is sowing and when it is harvesting, all this information in season crop area estimation, it will give clear information. And of course, our policies and planning, especially for the supporting land use, land cover planning, sustainable agriculture development way, this information also very crucial. And environmental and climate impacts also, it is many studies, it is really very helpful. And
sorry, voice is a little bit low. Can you speak up a little bit? Or every room on the back, can you volume up a little bit in the room? Thanks.
Okay. Yes, the main utilization of crop type and crop yield data mainly, to support farmers by providing welfare schemes, implementing welfare schemes, pricing, procurement, storage, and transportation. And of course, crop insurance projects as well. This is very crucial. Exact crop type maps and crop yield estimation, very precise way, it is very useful. And not only this one, mainly improving resource allocation, for example, helping government organizations efficiently allocate the resources and fertilizer applications as well. India, they are giving some kind of, support to the farmers. Based on crop base, they are giving discounts to the farmers, like fertilizer, seeds. Also, it is, so this information is really very crucial. And understanding agriculture pattern, as you all know, even scientists and government departments also, for particular location wise, what type of crop and when they are sowing, when they are harvesting, all this information is very much useful. So this is the reason we are continuously monitoring this one. And also right now at present, we are supporting Ministry of Agriculture in India and also state governments as well in this area. And mainly, ICRISAT is working on various thematic areas. Mainly, we produce near real-time basis, crop type maps, irrigated versus rainfed, length of growing periods, crop stresses, and crop intensity. For example, intensification of short duration legumes in fallow areas, and also climate smart villages, identifying, targeting the villages. Of course, these are the product directly generating from the satellite imagery along with the ground data, but we are integrating with some other biophysical parameters, secondary information. We produce crop suitability mapping, spatial modeling for prioritization, crop yield estimation, and water productivity assessment, of course, monitoring and evaluation. These are all the things we are doing. Here is some of the case studies, what we have done for last 2 years. Entire South Asia, we produced a cropping pattern, including cropping systems as well. 24 major cropping systems we mapped out for entire South Asia. And recently, we are empaneled in the National Crop Monitoring, that SOP also we developed. In that, every 15 days, after 1 month of the sowing period, every 15 days we are providing, government want to provide, needs this information, especially crop type and growth stages. So that's in-season crop monitoring also it is coming in. And also many case studies here, especially millet suitable areas. Very recently, we developed a model for suitable areas for the millet crop in upland rice growing areas. Especially some parts of eastern part of India, there are several problems are there. Now we are replacing with the millet. In that way, we can support to the farmers and improving the food production. And also crop suitability maps we are preparing for rice fallow areas and dryland farming areas. Also, we are recommending appropriate crops. The end users, of course, we are generating this information, but where this information is widely used by the scientists and government departments, especially breeders, system modelers, social scientists, hydrologists, and planning departments widely using this information. Of course, some of the adaptation strategies, crop insurance projects, directly including based on this information, they are paying the premiums. And also, we are closely working with the other CG centers and ADB and other national institutes as well. And now it is some of the key products in the recent last 2 years what we generated. Almost 26 crops we mapped out entire South Asia, which are irrigated and rain-fed crops, along with the crop intensity and irrigated versus rain-fed cropping pattern. Actually, we generated 1,500 ideal spectra signatures in different agroecological zones and different cropping pattern. Even rice alone, rice cropping pattern for Kharif and Rabi season. Nearly 60 samples, 60 ideal spectra signatures we generated, which is across South Asia. And also you can see here cropping systems as well, rice feed system, rice. And you can see all major 24 cropping systems in South Asia. Actually, this is done based on 3 years information. But very recently, we are working with the Landsat and Sentinel-2. We are updating this information. Especially in season, actually today's in season actually we use planet data. Especially this is for several state governments in India, especially Odisha, Telangana and Rajasthan. We are implementing. We use every 7 days data for entire the region. Like starting from here, you can see weekly 15 days I composed, but we used every 7 weekly data, and we produced these near in-season crop monitoring. For example, here you can see wheat November to March. This is the last season, just ongoing season from Rabi 2025. Wheat, November to March, December to April. You can see the cropping pattern for small area. And finally, these maps, they are overlaying parcel level information and parcel level, how much area, cropped area and crop yield estimates at parcel level we are generating. Of course, this is used by multiple, purposes. Government is using this information. And similar way, here is one of the, Haryana and Punjab also we are doing similar kind of things since last year. And this is for Telangana case study. You can see here 15th June, 25th June, how much area it is expanding. For example, cotton. Of course, we are doing for all major crops, but here I'm illustrating only cotton. Not only here, recently the similar methodology we are applying for Senegal also. Here you can see the field level information, how accurately we picked out. We tested machine learning, different machine learning algorithms and spectral matching technique together. And we already contributed a publication on this. You can see more information in here. Of course, machine learning, there are several limitations are there. Now we are trying to improve that information basically with additional ground information. But whenever limited ground data is available, spectral matching technique is really working very well. That's what we concluded here. And also finally, whatever we are producing the information, we are keep updating every 15 days in web portal for the public use and government use. For example, here you can see one of the village. Here, whenever you select the village, you can get area statistics. And when you click in one parcel, within the parcel, how many crops are there, and all these things you can see here. And the more information you can extract from this dashboard also. Yeah, this is the in-season crop monitoring, and now I will talk about crop yield estimation. Of course, as I mentioned, we widely we are using semi-physical model and DSAT crop model. Here, the overall framework you see, we are collecting a lot of AWS information, automated weather station, which is nearly more than 10,000 locations are there. That information also we are integrating, and field data, crop management practices, and other soil information we are getting from IMD and NBSS LUP, that information, all this information we are integrating together and we generate crop yield estimates at a point location. By using remote sensing technique, leaf area index is our proxy. Based on that one, we are extending large areas like this. Here it is the groundnut, but you can see the yield gaps also clearly. You can see here. This Actually, we are doing it season wise for major crops. Of course, the crop cutting experiments is very crucial. And previously, for one district, nearly 5,000 square kilometers area, usually they conduct 500 to 600 CCAs. Based on optimizing optimization CCA optimization, we reduced almost more than 70% we reduced. Yeah, we are capturing the similar kind of accuracy. We are capturing CCAs, that is for the validation. And semi-physical model, yeah, here is the methodology for semi-physical model. We are using PAR and FAPAR data, RUE data, also extracting from coarser resolution imagery, and crop maps and everything in crop maps and crop information we are extracting from Sentinel-2. And finally, harvest index we are getting from the MNCFC. Using that information, we are generating yield products at GP level, Gram Panchayat level, at village level. And you can see here the three methods we compared: semi-physical model, machine learning, and DSAT crop model. But there are some gaps are there, especially semi-physical and DSAT model. It is working really very good, very close to the reality. So we are widely using these two models. And here the comparison cross methods we compared together and we validated with the CCS data. There is a pretty good correlation with the DSAT model, DSAT outcome. And here there are some limitations are there, some advantages are there. Here we we compiled all these three methods, but out of that even semi-physical model, because which is very easier and straightforward, and widely entire India now their semi-physical model is applying many of the states. Of course, some areas we are using DSAT model as well, but mostly people are used by the semi-physical model in India. And we have contributed several publications on this. Yeah, this is, thank you all.
Okay, thanks so much. Yeah, that was so much work. Yeah, thanks so much for sharing this. Yeah, great. The suite of studies you already conducted. Any question in the room to Murali? Okay, so I don't see any hand at the moment. So, okay, good. So yeah, we will share all this slide deck presented today. So yeah, you will see, I mean, you probably want to go back and digest exactly what kind of work was done where. So maybe just Murali, one thing is because we have a lot of audience members from Kenya, because we are having this scientific event in Kenya. So a lot of audience members are either in Kenya or East Africa. So can you just quickly say how much of what you are doing currently in India can be also conducted in this country?
Sorry, Javo, in India?
Yeah, so how much of the work you've been doing in India can be transferred to Kenya?
Yes, certainly. We are doing for other parts of even West Africa also, especially for Senegal. But Kenya also, yeah, more recently, we are similar kind of things we are implementing in Malawi. But it is certainly possible for Kenya as well. We are very much happy to collaborate with our local partners as well.
Okay, great. Yeah, thanks so much for presentation. Yeah, so thanks for joining from India. Yeah, we miss you here, but yeah, I'm sure we will also continue collaborating and communicating with you. Thank you. Okay. Yeah, okay. Yeah, we will invite the next speaker. So yeah, let me introduce Siniro. Costa Jr. So Siniro is from Alliance Biodiversity CGIAR, and he will present digital soil mapping for carbon MRB in smallholder agriculture. Yeah.
Hi, hello everyone. Good afternoon. I think you can hear me well, right? Good. So as who said, I'm Sunil Costa Jr. I'm a scientist with the Alliance of Bio-Based in Theater based in Cali. And the idea is to provide you with some information on the work we are doing with digital soil mapping. So this presentation is called From Soil to Finance, Digital Soil Mapping for Carbon MRV in Smallholder Agriculture. So obviously I'm here representing a bigger team, especially my colleagues Javier Martin and Maese Silva. So in Cali, we basically run two labs. One is the greenhouse gas lab and the soil lab. And besides doing lots of measurements, we also build tools and technologies and like to apply these technologies. And one of the latest applications we are doing with our technologies related to finance. So we are trying to develop these tools that I'm going to show one of those for reducing the costs of measuring an MRV impacts of agriculture management and production and link it to climate finance in a cost-effective way. How can I move this? Okay, please go ahead. Yeah, so and the idea is to show here why and how we are doing this. So as everybody knows, there is a huge barrier or a limitation for scaling robust MRV systems, and they are need to unlock climate finance and accelerate agriculture transformation. And this is basically because with MRV systems, we can measure things, we can identify barriers, and plan how to overcome these barriers and be more credible in what we are doing, what we are measuring, and how we are reporting things. And being credible in this space means that we can attract new partnerships, new finance, new projects, and it's also build trust across entities, donors, financial institutions, and so on and so forth. But the big challenge in developing such scalable and robust MRV is basically how it's the affordability of it. So how to make it affordable for the agriculture context and especially for smallholders. Right? So that's the space we are working in. And here I brought to you an example related to soils, right? And next slide, please. And so before we go there, it's also important to remember what are the types of MRV systems we have out there, right? So we have obviously more simple MRV and more sophisticated MRV. And what is the difference between those? Is the type of level the type of data you need to collect to report back and to use these MRVs. So we built this pyramid that I think it represents very well the type of MRVs we have. On the bottom, we have the simplest MRV possible that is based on practices. So you actually track practices, and then you find impact in literature or with expert consultation, and then you associate this impact that you find in literature to the practice. So that's the practice-based approach, and and it's more basically a qualitative approach. Sorry, and that's why it's more simple and less costly. But as you climb up this pyramid, you increase the accuracy of the MRV, or you increase the accuracy of your measurements, but you also increase the level of sophistication and the capacity needed to run such an MRV. So on the top of this pyramid, we have, for example, the standards related to carbon markets, in which we need basically to quantify things. And to quantify things, we need to do first measurements. And usually we need to go out In the case of soils, we need to collect soils, we need to go to the lab and do all this process. That's why it is expensive. But we, again, are coming up with digital solutions to minimize the hurdle of implementing such MRV, and again, build more scalable and cost-effective systems to track agricultural practices. So next slide, please. And as I said, an example here with soils. So on the left-hand side, you have a traditional way of monitoring soil carbon stocks. That again, you go out there, you sample soils in a couple of field points or field sites. You bring it to the lab, you prepare the sample, you run the sample in equipments that can analyze and evaluate how much carbon you have in soils, right? But this is basically costly. It's necessary, but costly. We cannot scale measurements using traditional methods. We did a back of the envelope calculation, and we estimate that to implement such a field campaign and do all the analysis, we spend more or less $4 per hectare per year. Per hectare, right? And then the figure you see there is a 5,000 hectare group of farmers in Colombia in this case. And obviously we spend like almost 100K to do such a field sample campaign. And it's again, not replicable, not scalable. We need solutions for that. And in this context, we developed a digital soil mapping model in which we still rely on soil measurements, ground truth data, but we basically model and do soil mapping of the region. And in doing so, we are reaching very interesting results. Technically speaking and economically speaking. I will show you a couple of the examples later, but the model is having a very good accuracy that's ready for deployment at scale, and with 50% less costs associated to that, at least 50%. In some cases, we can reduce costs to 90%. It's really impressive the applicability and the power of such tools. And next slide, please. And how does that work? So we basically stack many environmental and climate layers on top of each other and build a model. And then in this model, it's basically, it's not an interpolation of these data points, but it's actually a way more sophisticated interpolation of these data points, because it can reads points in between. So we do not interpolate, but we take into consideration the soil properties between these data points that influence, in this case, the soil carbon stock dynamics, so that we can have a way more accurate manner to access how soil carbon and soil properties are changing over time. So we basically digitalize a region in the soil of the region, of course. So next slide, please. So here is the step-by-step of doing that. So we have basically 5 steps. One is the soil data and the cover rate scattering. As I said, is stacking many layers of environmental attributes, soil attributes, climate attributes, and a few others. We run and use machine learning and AI to build the model and be able to do the digitalization of soils, and then we do the spatial prediction and also evaluate uncertainty of the model we are building for this region. It goes through validation and final model selection. So I will not go into the weeds, but the presentation will be there, and then we can talk about the nitty and gritty of this process. So that's basically what they do. And then the idea is that, as I said, why the digital soil mapping is less costly than a traditional soil mapping, because you actually train the model, and later you need less ground truth to run the model and estimate soil carbon. So that's basically the applicability and how it reduces costs for monitoring soil carbon in this case. So next slide, please. So this, and we've been using this digital soil mapping not only to track and monitor soil carbon, but also to the step before. So as I said, we still need ground truth data. And with this digital soil mapping model, we can also optimize the soil sampling campaign that will be used to digitalize these soils. So basically what we do is a land certification of a given area. And then as you can see on the left-hand side, it's the land area. And then we move on, we are able to stratify by land use in this case, and soil properties in these land uses. With these two information, we are able to estimate how many sampling points we need to actually represent the soil organic carbon or soil carbon stocks of this region. So in doing so, we actually optimize the soil sampling campaign. We don't do that randomly, but we do exactly the number of soil sample we need, in this case, to reach a 90% confidence level with 10% uncertainty, which is basically what is required by most of the carbon market standards in the voluntary carbon market. So next slide, please. And applications for that. So I will show you two applications. One is in the 30 to actually 35,000 hectare smallholder farming region in Uganda. And I'm actually going to Uganda on Sunday to actually run the soil sampling campaign there. So the idea there is that farmers, they are is 35,000 hectares for 30,000 farmers. So what we are doing there, we are working with farmers, building a participatory MRV, meaning that farmers are working with us, collecting data and providing data to us that will support the land use certification in this region. We'll run the digital soil mapping exercise. We'll determine how many soil samples we will need across these 5 regions in Uganda. We digitalize the soil in this region, and from this point on, this region will be monitored using this technology. And we are doing that because we partnered with an impact fund that is managed by Responsibility. That's a Swiss-based asset manager. And Pablo, my colleague, is here representing Responsibility. And then this is an impact fund. And one clear KPI is how much carbon these farmers are storing in soils as a function of the investment. So obviously we cannot measure soils across these 40,000 hectares. So we need a technology that we can scale. So we are using the digital soil map in this case to report back to the investment. So that's a clear example on how this type of technologies can attract finance, can prove to financial actors that this is a credible tool to report back investors. And here we are with this example, right? Next slide, please, relates to voluntary carbon market. So this is a farm in a group of farmers in Colombia, in which we are using CGIAR or other CGIAR related technologies, in this case, improved forages developed by the Alliance Forage Program, that are forages adapted to this region. So we basically, in partnership with other actors, but we basically restored almost 7,000 hectares pasture lands in Colombia. We are also deploying this technology to monitor soil carbon in this group of farmers, 7,000 farmers. And with this exercise, we were able to develop one of the first voluntary livestock carbon project or a livestock carbon project in the voluntary carbon market. That we have already listed this project under Vera, so the link is there. It's publicly available, and I really encourage you to take a look. And again, to make this project happen, one of the major things that we did was the application of this digital soil map technology, again, to make it scalable, to make it cost effective, and to actually down the road generate revenues that are meaningful for farmers and not for people monitoring this type of projects. Next slide, please. Yeah, so to wrap up, I summarized how digital soil maps can support MRV. It can support MRV in many ways. So again, land stratification to optimize soil sampling, develop the baseline for soil organic carbon and be able to monitor it over time at large scales, optimize of number of soil samples that's related to land stratification, and again, it can really support farmers to tap into climate finance, as I showed these two examples to you. Thank you very much for your attention.
Okay, so any quick question? I think we have time for one or two questions. Okay, yeah, Reda, please.
Thanks for that. You mentioned that the model, the way you do this is, you know, an interpolation approach, but a modified interpolation approach or something like that. But in any case, my question, I guess, is that there are products, ISRIC soil grids and ISDA's products. How does have you compared what the values look like? Are they that different? Are the models that different? Yeah. What was the rationale in developing something different is my question.
Yes, no, that's a very good question. We also use these global databases in cases we don't have regional or local databases, right? Because otherwise we don't have anything to work with. But these, for example, soil grids is one of the layers needed to build the model, the digital soil mapping model, right? So we need basically the climate layer, the soil texture layer, that is soil grids, topography, and so on and so forth. So soil grids is one of those, and we use it for global level information. But in Colombia, for example, we have the entire country already digitalized and using data that we've been evaluating over the next decades first.
So if we wanted to use your approach you say you've done this in Uganda, but if we wanted to use it somewhere else in Africa,
yes,
we could, yeah.
So now we are in Africa. So now we are applying this technology in Colombia, as I said, in Sri Lanka, now agroforestry and tea. We are applying in Uganda, as I said, but it's a big area, it's 40,000 hectares. We are applying in Vietnam. It's cassava growers. And in Africa, we expect to also apply that here in Kenya, livestock.
I'll come and talk to you separately for West Africa.
Perfect. Yeah. Thank you.
How granular at a scale does this work on? Like if a farmer improves the soil carbon in one field, can you pick that up? And what's the time scale for picking up a change?
Yeah, that's the huge question mark, right? Because what the soil sampling campaign, as I showed you, right? $4 per hectare per year. But of course, you don't do that every year because you won't see any changes, right? What we usually do is every 4 years, 4 to 5 years. So this cost could be like a $1 per hectare per year using the traditional methods, and it would go down to 25 cents if we use the digital soil map, more or less. But changes 4 or 5 years if you are adopting a practice that is very different or significantly different compared to the baseline situation. Yeah.
Thank you. I'm an agronomist with interest in soil agronomy, and I've always also done some research in soil agronomy and with fodder, feed and fodder crop, which is sorghum. And my field was on soil salinity. Salinity is one of the areas that it's a quiet crisis currently with the climate change. And it's one of the areas that has been neglected. Like everyone is running from it because of its complexity in working on salinity. Now, what I want to understand and to know, because I've interacted with your Artemis, is are you working on salinity? Because when we don't solve this problem, also in the arid and semi-arid lands, it is one of the limiting factors. To the extent that some farmers are running from crop and fodder forages farming to planting tree crops. And not fruit crops, just trees. And one of the invasive trees, also I'm a Kenyan, and in Kenya, we have Magondo, Prosopis juliflora, which is invading the dryland parts of Kenya. And this tree is salt tolerant. And it is taking up the agricultural land and the tree again, despite its nutritional value for animals, it has some anti-nutritive value when taken fresh by the animal. To an extent that it removes the teeth, causing death. And remember, our ASAL communities, the indigenous communities of Kenya, are pastoralists. How are we going to solve this problem in salinity? And I would like to have more conversation on that because I also have a continuing work. I've done some and I would like to continue with salinity and AI. Thank you.
Sure. No, thanks for your question. I completely understand the importance of working on this topic. We haven't done anything related to salinity yet because we haven't come across an opportunity. So perhaps we should talk and build this up. But thanks for your question and thanks everyone. I think we are done.
Yeah, thank you. Now, so I will invite the next speaker, Ulatao. Okay, yeah, there we go. So on the agenda, it's actually listed as a loose get presentation, but he has a scheduling conflict. So Ulatao step up to present. So yeah, he's going to present closing productivity and soil health gap using this innovation. So over to you. Yeah, no, we will continue.
Okay. As mentioned, my name is Ulata Barra. I am a senior scientist at the Alliance of Biodiversity International in Seattle. So as mentioned, I'm representing USEC at Tamana. So most of this work is done through Sustainable Farming Science Program. So it's on crop productivity and soil health. Next. Just to start as a background, yield gap is one of the huge challenges that's not only at the national level, but also at the plot and at field level. There is a huge gap due to many factors. This is, of course, a fact across the global south. Recently, we did a survey using, during excellence in agronomy, we did a huge survey across the major cereal crops in Ethiopia. And we were able to identify the key factors, the determinants of this yield gap before this. So, yeah, here you can see, this is just for wheat wheat, but we did for major crops with maize, sorghum. For example, for wheat, you can see the first 2-3 factors are related to the climate data, the climate information, and then followed by soil pH status and other nutrient management like M rate, P rate applications. So that's one. And two is other agronomic practices related to the planting date, residual management, and all that. Next. So now, looking at this challenge, we wanted to develop a decision support fertilizer and soil health decision support tools that will respond to the major determinant of that yield gap, right? So here, you can see the first one is a planting date advisory. The second one is fertilizer type and rate recommendation, combining different process-based model, machine learning model, AI tools. And the third one is acidic soil management options, including lime and others. And the fourth one is around salinity issues. So you can see the solution we develop is more context-based, soil health-based, and climate-based. One thing here is that developing the decision support tools and generating advisory is one thing, but then once that advisory is developed, tailoring that contents into different forms into a typology. Can you go back? Okay, yes. Into resource endowment, a delivery channel, into a different pathways and partners' interest is hugely different. So I was discussing with our team here also, how do we really see that translation going from the content generation to customizing the advisory to individuals or the farmer is really a huge gap in our effort in general. Next. So I will mention a few things about the analytics, just to show you. It's a mess because in reality that is how it looks like to generate a good, advanced, accurate information of fertilizer recommendation in this case and the planting dates. So here you will have a data set. It's mentioned in the morning about the agronomic material data, soil information data, and other good agronomic practice data is the best to start all these solutions. Of course, you need to have a data partnership. In Ethiopia, we have this data partnership called the Coalition of the Willing, where we bring all interested parties to bring their data in one platform, in the National Research Institution platform, and we can use that data for addressing some of the big challenges in fertilizer and soil health in general. Then we use that to develop machine learning models, crop models, and we connect that to develop a response curve. For a given response curve, then we do optimization in target function so that we give site-based fertilizer recommendation for any farmer and any location. And of course, that has to be connected with forecast models so that the forecast model and the fertilizer recommendation model, they read each other so that the recommendation is also season smart, climate sensitive, climate proof. And then the other part is for acidic area. In some part of the country, it's really acidic. And then if we use only the fertilizer recommendation, the response is really poor. So it's very important first to address the soil health, the acidity, and combine that with the nutrient recommendations so that the response we get or the advisory responds better to this management. So this is just a whole workflow for some of this one. Next. Okay. So, for example, this is a platform. Once we generate the contents, we put that into a platform, an API, any demand partner, tap in, they access the contents and they can take. So this is, for example, for the nutrient or for the fertilizer recommendation. Next. As I mentioned before, you can see in the map, some part of the country is really acidic.
strongly acidic, and only the nutrient management, the fertilizer application is not helping to respond to the challenge. So we have to integrate with other acid soil management options, and we go ahead and combine all the available data in the country. You can see our model able to show, if we optimize all the inputs, we can see from the only fertilizer application, when we integrate with lime, we can be able to increase yield by 27%. And then when we add organic options, of course it increases, but it's not really significant. Then if we also try to look the varieties that are resistant to acidic, then it can also increase additionally by 20%. So going only from the nutrient management to acidic management and variety management, we can still increase around 47% additional. So you can see, especially the recommendation should vary in terms of what options need to be optimized given the soil health status, the baseline soil status. Next. So once we have that one, basically that means now for each pixel, and this I showed you before only for the fertilizer recommendation outside of the acidic area, but now in the acidic area, the recommendation for each pixel or for each location, you will have optimized nitrogen, phosphorus, and lime and organic options. And in some locations, of course, only NP or nitrogen, phosphorus can work, but in other locations, NP and lime can work, and in the other one, we need the whole integrated fertility management is working. So that's how we are targeting this one, and then we are integrating into the decision support tools where we have that challenges in the background in terms of acidity, then the nutrient density need to be updated to integrate the whole soil acidic soil management options. Next. So once that content is generated and available, it goes through the whole validation and piloting steps. We need to push this through dissemination channels. So we partner with the Ministry of Agriculture, with Ethiopian Ministry of Research, EIAR, and Digital Green Lersha. We develop various dissemination channels like Telegram, WhatsApp, SMS, and video, and we reach this content to the farmers through a multitude of options. Next. Now, as a part of our sustainable farming, validation steps, we have first the validation. So we did around 277 farmers in the first year, and the performance of our site-based fertilizer recommendation was really good. In that validation steps, 24% yield increase in comparison to the extension system, and the partial profitability was also high, around $600 per hectare. And then the following year, we did a piloting. The piloting was around 10,000 of farmers, and we did a data collection around 4,000. And the yield gain is even higher, around 38% of yield increase. So based on that experience, the feedback from the farmer and the demand partner, in the last 2 years, we have been disseminating this at a scaling and pre-scaling stage. We were able to reach around 75,000 farmers across the highland of Ethiopia. Next. You can finish the whole? Yes. So this will be my last slide. Now you can see the complexity. So there is land management, there is erosion, there is soil health status. Soil health could be many things. There is all the integrated soil fertility management. There is a variety issue. So we need to find a way how to integrate AI to capture all these dynamics in real time. So the next step we are working is how to integrate more agile, dynamic, process-based model, machine learning model, LLM model in capturing all this and give a targeted advisory at scale at a site-specific, but also at scale. So that's more or less the next front that we are trying to push here. Next slide, I guess this is my last one. Thank you very much.
Okay, yeah, thank you for presentation. Any questions, Udo? Udo? Okay.
So now let's move on to the next presentation from Marcel.
All right, thank you very much. It's really good to see all of you, and in particular, it's good to see so many young people. And I hope you're all interested in data and AI and all of this, what is presented, because it's really about you, because we really need your inputs and get this right. I'm a simple economist, and I would really like to get your inputs on this. Today, I'm going to talk about on behalf of a larger team. That's what I would like to acknowledge. Even though I'm presenting, there's really a lot of people and partners involved in this research activity. Oh, I can see here, that's perfect. Today I want to do three things. I want to talk to you about this very specific tool. Please go back to the first slide. I want to talk to you about a very specific tool, which is a digital tool called VarScout, that we're using for monitoring agriculture data. I want to tell you a little bit about what it does and what data we generate, and also the problems and challenges that we have when it comes to accuracy of the data and the representativeness of the data. And thirdly, I would also like to acknowledge or implicitly talk about the collaboration and partnerships that are actually needed to actually start implementing VarScout and maybe digital tool in more general. Next slide, please. Let's remind ourselves why we're actually doing this. I mean, there's a range of tools that are out there, but this one in particular is really about trying to monitor our innovations. And everybody wants evidence, everybody wants impacts and to demonstrate that, but there's only a handful of methods, I think, of how to do that right. And one of these methods that we're using are oftentimes in-person household surveys. But there are issues with that. Right? Even though they're very good, they're very expensive. They're very infrequent. That means we're only going to the field every couple of years to actually collect data. And they're very spatially coarse, right? And that basically means that we oftentimes don't know what's going on in a very local level and trying to capture the heterogeneity that there is. So more tools and methods are actually required that are cost effective, right? That collect real-time data, or more frequent data, but also at the very disaggregated level. And I think what's really key is here, when we think about these tools, that we do this without compromising on data quality. Next. So here we have VarScout, and what you can read in the box is basically what it is, or the ambition we have. It's a digital ecosystem to collect, store, and visualize varietal data, right? Agriculture data. And there's a couple of really key variables that we are at this point very much interested in. And that is adoption of our varieties, area that is cultivated to such varieties, production, and seed. And then the ... represents to actually whatever we're really interested in, because we can use this for a lot more. The metrics that we can then start calculating from these are abundance,
right? These are really then the information that comes out of the data. Abundance of our varieties. The varietal age, which is a measure of how much farmers can benefit actually from the genetics that we're introducing into farmer fields. Yields, obviously a very important metric. Seed replacement rates, which is more for our vegetatively propagated crops, where you can see that farmers save their seed for many seasons. And there's different types of users. We have been working a lot with extension agents, and I'm going to give you an example for that. We've been working a lot with school children. That's another use case. And then from the demand side, there are governments who would like to need or who need this data, funders that would like to know about the impact, private sector, etc. Next slide, please. Here you can see VarScout and the three main areas actually. It has a backend, which is all about a variety release database, where we pre-populate the different varieties that are actually already released in a given country. So from here, you can then start and collect the data. This is the middle picture and interface, where farmers, extension officers, school children can just have a drop-down menu and basically see what variety they can see in the field and then start recording that. And the last interface is then really about trying to visualize this type of data in maps. Next slide. I would like to highlight two use cases. One of these use cases is for seed systems development in Kenya, right? Where we're really having a lot of seeds, a lot of turnover, and we need to know more about our varieties that we're introducing into a given sector. The second use case is really about monitoring biodiversity. And that's really a big thing, right? Because biodiversity is really important, and there's different ways of monitoring it, which is, and one of them can be through VarScout. And I would like to highlight a use case from PIL. Next slide, please. In Kenya, and this is all data that came in 2024, so last year, what we have been doing is we have trained some 60 extension officers, and these extension officers, they were in 3 counties, in Nakuru, Bungoma, and in Meru. And they went out to go about their normal business, let's say, and they have started to collect within 5 months only some 23,000 observations. And you can see them here in the table for 3 different crops that we were mainly interested in. So it was maize, potato, and beans. And these represent 12,000 unique households. So basically they went to a household, they obviously recorded most of the times, all the time actually maize. And if they also had the other crops, they also noted that. So here you can see on the right-hand side actually where the data actually is. You can see at the national level from Kenya where we have collected the data. If you zoom in a little bit, you come to Nakuru. If you zoom in a little bit more and then a little bit more, you actually see how representative the data seems to be, and that there's not so much overlap, and that the extension officers actually did a quite good job. Next slide, please. So what can we learn from this data? I think there is many lessons. One example is obviously on varietal adoption, right? What's out there? What varieties are out there? And it's really striking if you see at the bar chart that there's one particular variety that's really dominating the landscape for potato, and that is Shangi, right? For good or for bad. It's really up to us to now see, why this is the case. Is this because of accessibility to or inaccessibility to other varieties? Is it affordability? But this gives us a really good understanding of the dominance of certain varieties. Another thing we can really conclude from here is that the SIP breeding program has been really important in Kenya. And about 80% of the adopted varieties stemming from the material of the SIP breeding program and the gene bank. Where's the private sector? It's another big question. I don't see any varieties. Maybe it's time now really to start engaging with the private sector more to see how we can get their good material into the fields as well. On the right-hand side, you can see a map that is now calculated, which is the weighted average varietal age, again, which is a measure of varietal turnover. So again, here you can see that the boxes or the grids that are in really dark reds are the ones where you have varieties that are really old. So farmers are not making use of newer material. Whereas if you see grids that are colored in green, you actually see varieties that are new. So now you can basically deduct from there, if you want to have an intervention, you can see, okay, where do I target my intervention most? Not everywhere, but you can be very, very targeted. And there's another box here where we have more of the VAFA, so that's varietal turnover, differences between the different counties also in terms of the use of clean seed and also yields. And I think this is really data that governments and partners are really not needing. Next slide, please. Let's go to maize. Here, the example is for the 12,000 observations for Nakuru, and I think that's really important. So we don't claim national representation. So here, the same story, we can deduct adoption rate, we can see dominance of specific varieties. I'm not an expert in maize, but I would like to draw your attention to the graph on the right. Here we plotted the year of release of the varieties when they are released against the average yields. Okay, what we see at a snapshot in 2024. And what you can see here is obviously that newer varieties, they actually yield higher, right? So that tells us, if you plot that, that farmers in Nakuru, they're actually benefiting from better genetics that the CGIAR and partners and private sector, etc., that we have been actually releasing. Next slide. Let me talk a little bit about the research also behind when we're really thinking about getting better and cheaper data. And there's three important measurements. One of them is varietal identification, yield predictions, and area measurements. Let's start with the latter. Area measurements, I think we already have under control in the sense that within VASCOUT, we are able to use the GPS coordinates rather than farmer recollection to actually get pretty accurate area data. Varietal identification is still largely used, collected through farmer recollection. So there is potentially an issue. So the gold standard had always been the DNA fingerprinting, where you take a sample, you send it to a lab, it is then analyzed, and after months of time, you then finally know what the true identity is of your variety. That's not real time. That's not cheap. So what other ways are there? So I think we can make better use of AI and image recognition to actually solve that problem a little bit. And here we have been working closely with our partners in NIAB to actually build models that help us to identify varieties. We've done that for wheat, we've done that for potato and sweet potato, and it's upcoming. Yield prediction, similar story. We're using crop cuts, very expensive. You go, you dig up the soil, you start, and not only soil, anything. It's very expensive. And so here we're using usually farmer recollection. That's also pretty inaccurate. Again, here we're asking, what can the contribution be of AI and image recognition? For some crops, that's easier, that are above ground. For example, what you can see here, I don't know, can you click one slide further, then the entire picture will come up? Can you proceed? Yeah, perfect. So you can see, I don't know if you can really see that, but it's an aerial picture of wheat. And the AI model basically is starting to count the different ears. And then based on that data, predicts the yields. For underground crops, such potato, cassava, etc., that's more difficult. Next slide. Let me talk briefly about data triangulation and really about trying to see, making a comparison between our adoption data that we collected through VASCOUT and actually a different source of data, which is coming from seed sales. So we've been partnering with AgNexus, which is an agriculture advisory company, and they are getting the data from agro-dealers. And we have now overlapped our area with the area that AgNexus is working on, and there's like 43 outlets that are overlapping in our area. based on the seed sales data and our adoption data, we can actually see that they compare fairly well, which is really good news. Obviously, there is no perfect match between these data points, and there are good reasons for that. And some of the reasons are highlighted here. For example, that in the Vasco data, more than 25% even of the maize data as well, farmers are using farmer-saved seeds. Obviously, that's not reflected in the seed sales data. The seed planted can also be that is bought from the agro-dealers. They are outside the locations that we're observing with Vasco. Could be another reason. And so you can see there are multiple reasons, and one of them could also be, for example, that we haven't or that we have misidentified the varieties that are out there. Next slide, please. The other use case is really about monitoring biodiversity, and that's a really interesting case. So here we have been going to schools in Peru, and we have trained school children on the use of Vasco. And then on the International Potato Day, which is a public holiday in Peru, children go home. And then we have kind of set up a nice competition. And then they would go out and monitor all of the potato varieties that they see in their own fields, and the neighbors' fields, and then their environmental fields. And oftentimes it's not unusual that farmers have 40 to 50 different varieties, which is big. So this is all then nicely put into a repository that you can see here on the right-hand side, which is called Wikipapa. And here we, about 200 school children have gone to 1,300 households, collecting 3,400 observations, and really identified 2,400 different varieties. I think that's really an interesting case. Next slide. In conclusion, I think we need more cost-effective tools, more real-time data collection that allows us to collect data at very spatially disaggregated levels to really pick up all of the heterogeneity that is out there. We need to go a little bit further than what we have been doing at this point, and we really need to look at trends. So we only have 2024 data, but the trends we would like to pick up across time and space, and I think there's really big opportunities. We have been doing this work from an angle of supporting breeders and seed systems, but I think this tool is much more than that, and we can also use it to monitor CGIAR innovations, actually any type of innovations, the bundles. And if you think about biodiversity, even underutilized crops, some things we actually really don't know of. And we should do that with our partners, with extension officers, I think, when we're building really strong partnerships, as we have done in Kenya, for example. I think we need to obsess more about data accuracy. And I think AI is really a really good direction that we can move this into. And there are really strong demands. The Kenya government is really interested, but also from a really at a higher level, the Ministry of Ag in Agriculture is interested in Zimbabwe to actually adopt Vasco really as a monitoring tool. And finally, and this speaks about the business case, and I think to every digital innovation that's actually out there, how are we making sure that this is sustainable and it's not going to our AI graveyards? So in linkages with the private sector are really important. With this, I would like to close. Thank you very much, and looking forward.
Thank you. Thank you so much, Marcel, for sharing your experiences with different methods for monitoring varietal adoption. So if you remember the title of this session, the entire session, the whole day, is Digital Innovations for Advancing Research in Agri-Food, Land and Water Systems. So something like this morning, we'll be talking about the importance of human-centered design. Some of the speakers also talk about the importance of standardized data. So now we have a very interesting presentation from Jacob Barrete, who's going to talk actually about the data management side of things. Question? We can take, okay. Before to move to Jacob's presentation, we will take some questions from Marcel. Okay. Can you use the mic, please?
Good afternoon, everyone. My name is Aida Nganga, and representing UNESCO Emerging Technologies and the Women in STEM Leaders Network. First of all, I'm very excited about this because my area is AI, definitely well, AI and IoT and blockchain, those technologies, using them for good, for development. Excellent work. I'd really love to see it at work, but I'm wondering about how long have you implemented it? Do you have the numbers? Are you able to iterate as you move? And also, are you able to sort the bugs out as fast as you are deploying this with the users? Thank you. And how difficult is it? And how are you dealing with it? I've got so many questions, but I'll leave that to you.
Sure. Yeah. Are there any other questions? Can take maybe some more. Yeah.
Good afternoon, everyone. I'm Victor. I'm an agronomist, and I love the presentation. Actually, I'm asking about does VAR Scout have an application? And if yes, can you use it locally? Thank you.
Yeah, great. Thank you. You? Yeah, sorry. Yeah, go ahead. Oh, yeah. Oh, yeah.
Sorry, I work with bean varieties. A lot of times farmers don't know what variety they're growing. They only know like the market class, and even looking at two varieties next to each other, they don't necessarily have any indication of any difference. So how do you handle that problem?
Yeah, good. I'll take one more and then I have to respond. Please go ahead.
Mine is a quick one. The potato variation, especially in Bungoma. So have you been able to identify why the farmers prefer one to the other? Is it because of the nutritional value? And do you do any nutritional value on any of the products or whatever you're handling so that you can get to know why the farmers prefer what? Thank you.
Good. Yeah, these are nice questions. Let me quickly respond. And I'm starting also with you. So why adoption? We don't know. We're just providing the evidence of that something is or not adopted. So the next step would then be once we're finding interesting trends or something that is surprising to us, for example, in Bungoma, where we, for example, see that yields are low and seed replacement rates are high, we go out and ask why. But then that requires more research and more activities. Yeah. On the variety identification, yes, we know that's very crop specific though. For some crops, we're better and more able to identify it than for others. That's also why we're working towards AI. Having said that, in our model using extension agents, they are basically trained on identifying varieties as well for particular varieties. That's why we have to release databases as well, pre-populated with pictures, with other information, right? So that they are in the best way informed to ask and identify the varieties, right? So it's basically a group effort between the farmer and an extension agent. But we see a lot of value, obviously, in the AI part. Is it available? Yes, I'm such a bad marketing person. Yes, I'm a simple economist. Remember. Yes, it is out there, and I should have put it on. Yeah, you can download it on Apple Store, on Google Store. You can register, play with it, and yeah, drop me a line and let me know how it goes. Yeah, absolutely. About the last question, we have only started. It's a process, right? And we've been working. We know that the success of this tool and maybe other tools hinges on the partnerships that we have. So we're investing a lot in it. And my colleague Dina, who sits next to you, yeah, she's been instrumental in doing this work in Kenya. So we're building close relationships with the local governments, right? And in order for them to help us. So we have only started to do this work. That's why we only have one round of data collection. And we would like to do this more. Hopefully this year we have another round, so we already have some trends emerging.
Okay, hopefully we can work together. We have a wide network, and that is our specific area. Well done.
That would be wonderful. I don't know if I can take some more or not. If there's interest. Yeah, okay. All right, great. Then if I couldn't answer any other questions, I'm here. We can maybe meet or send me an email. Thank you all very much.
Thank you again, Marcel. So as I was saying previously, like as this session is about digital innovation for advancing the research in our food, land, and water system, so it's also good to hear about the data standardization, the data management side of things. So Jacob Van Etten is going to share with us some experiences with across with CGIAR and non-CGIAR.
Thanks. Thanks, Daniel, for introducing me twice. I'm going to talk about data. Can you go to the next slide? Not only being introduced twice, I'm going to say something in 5 different ways. So it's like saying I love you in 5 different ways. You can say I love you with chocolates, with flowers. I'm going to say with 5 different examples the same point. Standardized tools and metadata increase the value of our data manifold. And we have the tools now to do that. Let's use them. And let's invest in those tools and using them more and more. Can we go to the next slide? So 2 inspiring examples from outside the CGIAR, where we show that metadata and standardized data are really providing value. I think a very inspiring example is GBIF. Who in the room knows what GBIF is or means? Can you raise your hand, please? I see 1 hand, 2 hands, very few hands, right? It's not agriculture per se, but it's about biodiversity. It's very close. So this is the global biodiversity database that we have from many countries. Go to the next slide. With a very interesting model on how to use data. So it's a very big database of biodiversity data. So if I have an observation of a bird, for example, even if I use my an app like eBird, for example, if I am really into birding, that observation goes to a database that is managed by GBIF, and they hold most of the biodiversity data, I would say, in the world in a single database that is used for publication. So any publications that you later see on how do bird populations respond to climate change will use this data from GBIF. How does that work? How have they been able to put all of this data in the same database? You see the 3 ingredients of success. So standardization of the data. So really using same data formats, agreeing about these formats, and then everybody using the same formats. International cooperation. So getting this collaboration in all these different countries. So every country in the world, including Kenya, for example, here has a focal point for GBIF, who manages the kind of uploading of all the data and awareness about GBIF in the country. So if I'm a researcher at the University of Nairobi, I do research about snakes, for example, and I have data about where the snakes occur, I will be uploading that to GBIF, and I know who that focal point is in the country to upload this. But the other thing, and I think that's a very interesting one for us as well, is about citation attribution. If I do snake research in Kenya, let's follow that example. I want, when people use my data, I want to be cited, right? Because I want to be recognized for the work, hard work that I did. I don't want to just somebody else publishing that data and not even telling other people that that was my data. So GBIF also has a very nice system in place that tracks the data. So when you send data to the system, it knows that from who it comes, and then when it's cited, you can kind of get your credits for that. Yeah, and that's very important in the scientific world to get that kind of buy-in from the database. Next slide, please. So this is how it works. So this is just one aspect of their model that I find very interesting, which is about how they make the data traceable through the system. So they give every data set a DOI. So every publication of scientists has a DOI, which is kind of a standardized number. They do the same system for data sets. So if I have a data set, it gets a unique number, and that makes it possible to publish that when you publish to mention that unique number of the data set, and that allows you to trace back where the data came from. So also, if there's a problem with the data, you know who actually created the data. Yeah? And some publications use
many data sets. If I'm going to publish something about bird migration from between Europe and Africa, for example, seasonal bird migration, and maybe using data from Sweden, but also from South Africa, for example, and everything in between. So then it becomes very important to have this very solid system to be able to put all these data sets together and to know who did what. Next slide, please. So the other inspiring examples from private sector. So GBIP is more research and more public, I would say. Bayer is a company that does, among other things, of course, medical research and also agricultural research. Bayer has been very successful in organizing in their organization a system that makes all the data very standardized, searchable, and so forth. Can you show the next slide, please? I'm not going into the details, but in the past, Bayer also had the same problem that many research programs had very fragmented data. Data was in different units of the organization. So then for many research problems that have a commercial application, you need data from different units. Yeah? So we have a new pest problem coming up, and I want to know what could solve that pest problem. And maybe there's some data in some trial that it could be useful for that problem, but I don't know. And maybe I need to talk with that unit then. If I'm the commercial unit, I need to talk with the unit that looks at pests, and look at the unit that looks at pesticides, and then my eyes need to puzzle the data together. And sometimes I just decided to do another trial, basically, and go back to the field, because it's more difficult to go into the archive than to do a new trial. Now with this system, they're doing many things, but research is very fast and also cheaper in that sense. So, for example, one of the main things that is happening, one big example is when you have a new disease occurring in a crop, for example, but also in humans, by the way, and you have existing research where you can do the discovery of the molecule in your own data sets. And sometimes they've been discovering you have a new virus coming out, for example, and they already had a molecule that was good for like fighting that virus, and they already had trials for it, and sometimes it was even already admitted to the market. So they could just market an existing product for a new upcoming disease. Now that's the cheapest research you can do, in a sense, right? And so you avoid all these phases of research that you have by having really your own data organized. So even in the economic sense, having your own data organized really has a dollar sign on it to do this, instead of doing new research, using existing research to provide solutions quicker for emerging problems. Next slide, please. Another, I hope, inspiring example. So now we go to the examples from the CGIAR. Is the periodic table of food initiative. So periodic table, I hope you know what a periodic table is from your science classes in chemistry. All your elements are up there. So this project tries to do something for foods in that sense, right? What is the actual nutrient content of different types of food? And getting all that data together to make decisions about nutrition and about better diets and so on. Next slide, please. And of course, that's a lot of data to answer these kinds of questions. So what is actually in the food we eat? So a lot of nutrient content research. How does that vary? So you could look at, say, carrots, but vitamin A content in carrots is not the same depending on the variety, depending on where it's grown and the soil and so on. So they do a lot of research on these kind of factors of influence as well, and that is also part of the database. And then also, of course, the big question is what kind of consequences does that have? So a lot of data. Next slide, please. And a lot of organizations participating in it. So imagine you don't have a system to standardize your data and organize your data well when you have a project that looks like this. That would be crazy. If everybody would be managing spreadsheets and sending them by email, I think you would become very, very crazy at the end of such a project. So this project has made a big investment in actually creating the structures and the metadata, describing the data very well, to be able to organize that.
And then you can actually answer very interesting and important questions with these data. We can start to compare between different data sets. Next slide, please. So let's maybe, so this is the process. Let's skip this, but you can look at it in the interest of time. So what comparisons that you can make with the data set. So you can take one sample and say how special is this sample compared to the rest, and then you can define what the rest means. So if you take one category, so in this case, if you take out one strawberry, raw strawberry, and say how special is a raw strawberry compared to all berries. So you have a lot of berries, blueberries, etc., and you can here see how special it is in terms of a Z-score. So it's and then for the different types of nutrients it has. So it has a lot of sugar actually compared to other berries. It has not a lot of cadmium. Oh, that's good. The sugar is bad, cadmium is good. So you can make these kinds of comparisons. You can only make these comparisons when your data is really organized in the same way, right? If say the blueberry researcher had organized the data in a different way than the strawberry researcher, you would never be able to compare things. Next slide, please. Another example that is actually a product of CGIAR again, and led by ILRI is ROMAS, the Rural Household Multi-Indicator Survey. It's an effort that is being led by ILRI and with many contributions from other CGIAR centers, universities, etc., to look and do the same thing with household data. So again, another way of saying I love you. Data is important, but now it's socioeconomic data. Next slide, please. So what is the need? Same thing. Fragmented, incomplete data in households. Everybody has a lot of household data on their hard disks, on spreadsheets. They're all different, and everybody asks the different questions, right? If I work for a center that looks at one crop, I mainly ask questions about that crop, and I forget, for example, livestock. If I work for ILRI, I ask a lot of questions about livestock, I forget about vegetables and irrigation. How can we make sure that these surveys are much more comparable? And this is a big problem. So CGIAR is estimated 180,000 surveys of households per year. It's a big volume of data. If we cannot do it, it's a huge wastage, right? And we can really not justify not standardizing this. ROMAS has been trying to do this. Next slide, please. By building this kind of system, so you start with where the data comes in. So it's something you cannot start by doing after the fact, right? Once you have the data already, you can never repair it again, or it's very difficult when you have the data. You need to build a system that from the beginning is very deliberate in how you organize your data. So when you design your questionnaires, it's already standardized and it's already linked to, for example, indicators. It's also a very important principle for household data collection, is that you don't do it based on curiosity. I would really like to know this about households. And you do that with a group of people, of researchers, and the survey gets longer and longer and longer. And at the end, every farmer that gets interviewed gets very bored with all the questions. This is also a very good way of actually looking at that in a very careful and critical way, and make it based on indicators. What is the actual questions that we want to know? What are the indicators that we want to be able to calculate? And the indicators then lead to what kinds of questions do we need to be asking to be able to calculate those indicators. So there have been surveys as well where you ask for a certain indicator, you need to calculate a certain indicator, you need 4 questions, but you only ask 3 out of those 4 questions. So you've wasted a lot of time and you've not even been able to calculate the indicator. This is a much better approach for that. Next slide, please. I'm simplifying a little bit here, but just to explain the principles behind it. And then these kinds of data address many aspects, right? If you go to a rural household, it's about many SDGs, so to say. So you can ask many kinds of questions. It's not that every project is going to ask all of these questions, right? So different projects have different goals, but if you ask these questions, you want to do it in the same way so that when you measure things, you can then link it also to these global development goals that we're all contributing to when we work for the CGIAR and other organizations that work towards development. So that's so there's the core modules that are included in every survey, and then you can also pick optional modules that have been developed that depend on the particular questions. You can also always also add your own questions, of course, but for many questions there are already modules developed so that you can also standardize it, even if the project has a particular goal. Many of these things are already included in existing modules. Next, please. So that has led to a lot of data points already and a lot of collaborations. I don't show the logos to be part of all of this, but just to show that is part of the problem that this kind of solution is trying to address, right? How do you make all these organizations collaborate and make something together? That is possible with these kinds of solutions. So it's being used in 130 projects already, many different partner organizations, and that has also led to very important publications about trends in rural development. Next slide, please. Just one little example. For example, drawing different data sets together to support an intervention decision in Malawi. One of the other interesting aspects of this is it's quick, right? So because it's all standardized, you can then also analyze it very quickly. It's not that you have this survey and then you have to think about how you analyze it. No, the analysis, how to calculate the indicators, all the software for that is already there. So it's being used by NGOs, for example, in this case, in Malawi, to monitor, right? So you can do this survey very quickly. You can look at your baseline within the project. Many times the baseline, you know it over here and the project is ended. You have the baseline, make decisions within the project. Next slide, please. So one solution that comes from our team is CleanUp. This is about on-farm testing. There's also been an area where we had very fragmented efforts over a long period of time. Where we try to address that as well. Next slide, please. Okay with time? 2 minutes? Okay. So the need, very fragmented data, low volumes, not standardized data, these kinds of things, and then putting it in an Excel spreadsheet. That was the method. Next slide, please. What we do was to develop a standardized method to address this, so the data comes in a very standardized way. GPS points, software, and so on, and then being able to link plots with GPS points to climate data. That's what you see in the right lower corner. Next slide, please. And this is an overview of the system. I'm not going to describe it, but I just want to point out two things. There's a computer at the beginning and a computer at the end. So the process doesn't end with the computer only. You start the process when you design a trial in this system. You start it on the computer, and everything is standardized, and that makes it possible at the end to produce a report in an automatic way, because the system already knows what you're going to do. I'm going to collect yield, for example, and it already says yield, and at the end the script, the software already knows this column is yield. That's what I need to pull out here and calculate something. Yeah? If you only have the computer at the end in this kind of thing, then you have a problem. Next slide, please. And then when you have these kinds of data, again, same thing, you can have many organizations together producing very interesting science by being coordinated. So we have been able, in this case, to put 4 different breeding programs, various organizations, or 4 organizations in 4 different countries together, by doing on-farm trials, in this case beans, in different projects sometimes, or different funding, but still, because they use the same format, in the end, we've been able to put all those data together and to create a variety recommendation map for the whole region, for all 4 countries. And that led to very interesting insights that some varieties developed for one country were really well adapted to the conditions of another country, for example, and that has led to new research as well. Next slide, please. Conclude. So again, 5 ways of saying I love you. What did I say? Enormous potential benefits from having standardized data, more value, including dollar value. if you properly document it of your data. And also for the dreaded words, also if you're going to do AI, same thing. And actually, when you're going to do AI, you even more deeply realize how important all of this is, the data standardization. It's not that the AI is going to structure your data for you. Yes, it can do it, but that's very unwise to do that. For standardized data, people need to start with protocols and tools. You cannot start at the end. You need to start at the beginning, like in everything. You cannot retroactively design good data. You cannot take a database and going to redesign this. Then it's good. It needs to start before you collect the data. So there are many tools already. We have 3 examples and many more tools in the CGIAR. Let's use them and let's also keep improving them. They need also more investment. There has been quite a big effort as well. Also, the funding has been very fragmented. We need to make a better effort with, for example, the Digital Transformation Accelerator to move this field forward and to keep working on this. Thank you very much. Thank you, Jacob. We can take one question for Jacob. Please, go ahead.
Thank you very much for the presentation. We all went through the arms of the teachers, and teachers, whatever teachers, when they teach us, we always remember what they have taught us. Are you seeing a possibility of the periodic table on food going into the school curriculum so then they will remember?
Very good. So yes, I think it's a very important question to go into the school curriculum. Like I showed 3 examples, right? I cannot really discuss for all 3. Within CGIAR, we have efforts to work with schools. So the last one example is from my own team, the most deep effort, where we're most deeply engaged. Sorry, we work with the breeding programs, for example, to put this into the school curriculum. If you're interested, come to me. I'll give you some material on that. And we're very interested in actually building this into more of the breeding curricula, especially at master's level. Very good question.
Thank you, Jacob. Okay, so just one more presentation. Okay, so I wanted to sum up what we've seen so far in this block of the session, which is how new methods to evaluate varietal adoption that are more adapted to the needs of agriculture nowadays. We've seen Jacob talking a bit about that, but also about data standardization and the importance of that. But now, let's assume that the data has been already standardized and curated. We're going to analyze the data. Then when we're analyzing the data, we realize that some features are underrepresented. I mean, some of the people that has been involved in the analysis of data, they know that it's problematic because the models are not generalizing well, that there is something that is called algorithmic bias. So in the next presentation, what we're going to see is a tool developed by the CGIAR actually called the Multidimensional Inclusivity Index, which actually is made for that. It's made in order to avoid that the data that's been collected comes with the bias of is being underrepresented or overrepresented by male and underrepresented by female.
Okay.
So Inga, thank you very much.
Thank you so much. Thank you very much. Good afternoon, I guess it is now. I understand that I am standing between you and your lunch, and so I'm going to try to be as quick and hopefully as vibrant as possible and presenting a pretty cool tool process developed under the Digital Transformation Initiative by a few centers. And so this, like what Marcel also presented, is a team effort led by my colleague Angie Garcia, but also colleagues at IRI, at the Alliance for Biodiversity, CIAT, IFRI, and hopefully perhaps even others. The tool is really about trying to understand how we can embed inclusiveness into the design of digital tools, right? And so that stemmed from this big challenge that we have where tools developed nowadays, many even within CGIAR, are often not used and accessed by those that they are intended for, particularly women, youth, and other underrepresented groups. So the idea, this team had this vision and a goal to look at how could digital inclusiveness become the norm in agri-food systems in how we design digital tools. Thank you. And so this notion of a multidimensional digital inclusivity index was born as an enabler. The idea was that it would provide a scientifically robust process to evaluate and inform inclusiveness in digital tools. But besides actually evaluating inclusiveness, we found that it could actually, do a whole bunch of other things like identify actions, risks, recommendations for the design of innovations. It could enhance ethically and socially inclusive use of these tools. And so there was a whole bunch of other real practical outcomes once we started to test the tool. Thank you. So what it was an evaluation framework that was designed, so an index, that was made up of a whole bunch of indicators looking at innovation usage, so measuring the availability and accessibility of the tool for these different marginalized groups. It included usage effectiveness, so that was assessing the ease and the effectiveness of the use. It even looked at the supportive ecosystem around, the tool. This was particularly important in the adoption, right? Then it also looked at stakeholder relationships as well. So that was how did this tool ensure ethical practices, responsible innovation. It also looked at the co-creation and the governance. Right, so especially the ethics and the governance around the design and the deployment of these tools. And then social consequences. What were the positive but also the negative consequences once this tool was, being used? Thank you. The next slide. So what we came up with after we designed this index was then an evaluation framework. So basically an innovator designs a tool. They send it to the NDII team. The NDII team then, comprises of different evaluators. Farmers, for one, could be either, evaluating the tools as a user or a beneficiary. And then we had the expert group. Those could either be the technical, digital innovation experts or the gender and social inclusive experts as well. And then they evaluated the tool based on the index, computed the score, gave it a score. They engaged with the innovators, and then the results could be displayed in a dashboard like this. Dashboard is online now for one of our big projects and partnerships with FAO. So you can take a look at that if you want to. But basically, it had a whole bunch of different dimensions, some metadata overview. It even included the voice of beneficiaries. That was really important. And then it also could show what are like the 5 top digitally inclusive tools. Right, so a whole bunch of functionalities as well, from qualitative and quantitative insights, customizable data views, interactive visualizations that allows the innovator, the team, to also track how they are doing over time. If they want to see how can I refine my digital tool over time and what does my score improve, they can do that. They can see that through the dashboard. Okay, thank you. The next slide. So we tested this in a few projects. The first one was FAO's WAPOR, which is basically this portal for FAO to showcase water productivity across different countries using remote sensing data. And there's a whole bunch of tools, digital tools on the WAPOR portal. So we looked at the area yield tool, for example, implemented in Ethiopia. And you can see there, that is the NDII scoring. It includes the indicators of the overall evaluation, but it also includes the user score and the beneficiary score. And then it includes a nice report, right, on the level of inclusiveness, but also what the innovator can do to strengthen that. For example, the perceived relevance gap is one of the outcomes. It says downstream beneficiaries report more concerns, inequality and empowerment of the tool than direct users. And so this could highlight a disparity in equality embedding, and then later give some recommendations on what the innovation team can do. Thank you. Next slide. So that was one example. We did another example of an irrigation performance assessment tool for Mozambique. And you can see here, because this tool is still in development, it's ex ante, but there are some sort of identified risks of exclusion and then some practical JC recommendations that the team can implement. Thank you. Next slide. But then it wasn't only, these kind of tools that are used by country teams or decision makers. We then also tested it with the research teams. And the IRI team was kind enough and wonderful enough to test it with their rice crop manager tool. And I think you can do the next slide, thanks. And so they applied it in several countries, in India, in, what's the second country? India and Indonesia, sorry. Eyesight is getting tired, last day of the science week. So yeah, they applied it in these countries, and it was interesting because you could also see how the tool could be refined in Indonesia, because it was still sort of being tested there as opposed to already rolled out in India. So that was quite good. Thank you. The next slide. And then we didn't stop there. We also then tested it with agribusinesses. Must be honest, biased view, but this is where I got most excited because I work a lot with agribusinesses. So we worked with agribusinesses who develop digital tools, and we wanted to look at how could they expand their market segment to reach more women farmers or reach more youth farmers, right? So we tried it with Farmer Line in Ghana, which is also an irrigation app, and it looked at their business to farmer services. We also tried it with Virtual Irrigation Academy. They developed some soil moisture wetting front detectors, some digital tools to detect levels of moisture in soil. And in fact, through the testing of this, also helped them develop a market expansion strategy to reach more women farmers. Thank you. Next slide. So I think there's been a lot of work done, to test the tool, first develop and test. Now it's really to look at how we can implement and roll this out. And also interesting findings around how through this process of improving digital inclusivity, we also found very big gaps, capacity gaps in innovation teams. A need for CGIAR to bring its digital work closer together with its JC work, our gender and social inclusive teams, and for both teams to see how they can sort of change and adjust their approaches, because they tend to speak sometimes different languages. So lots of other lessons learned, but happy to share more and also exchange with the design team if you have any questions. Thank you. Thank you both. Thank you so much.
One question. Okay, thank you so much, Inga. Thank you so much. Another great word from Amy. But something that you guys haven't mentioned, but during the session, we've seen examples from Amy, the digital twin, and the AI. And those are digital innovations that have been developed within 2 years. So congratulations there. So we have time for one question, and then we will move to the wrap-up. Ram is going to do the wrap-up. So do we have questions for, okay, 2 questions. And then you.
Okay, thank you very much. Very interesting. And I didn't know that these two, so I was thinking.
That's just behind her. Okay.
Huh?
Well,
okay. So I think very nice guideline and tool having to guide our development. So this seems to the last mile evaluation of inclusion. I was also thinking how we look into
the algorithms, the data representations, how the content could be biased and, unrepresentative in the information itself. So there is a last mile issues, and then there is a middle mile bias and challenge, like the one Daniel mentions, algorithm challenges. So is there any workaround like evaluating that kind of standard evaluation of bias and ethical issues related to data in generating the informations? I don't know if it's clear.
Should I answer briefly from myself? I mean, definitely there are biases, right? Because they are the expert-based qualitative reviews. So that would be like an individual perspective. But because the process is so tailored towards one innovation, right? Understanding it with the design team, that workshop process afterwards, I think, acknowledges it, but it also helps, accept it, right? Because it's also about how do you help an innovation team reach scale with a digital tool, reach, women farmers. There's also very different groups, right? So it's not just like one, that's what we found. Women farmers, not just one group. So having that kind of index that would allow you to have different demographics, different types of women farmers, also sharing their information, right? So the more you can get aggregation, that also seems to help the teams, especially the agribusinesses.
Jimmy? Yes, thank you, Jean-Marc. Two questions very quickly. First one is, it's great to see this multidimensional digital inclusion indicator, but how heavy is it on the side of the team developing an app to include the necessary bits of software inside the app so that we collect information about digital inclusion? And hopefully we would like to have it as a minimal extra burden on the dev team to add these bits. And second question, have you ever started talking with platforms distributing apps such as the Play Store and the Google App Store and the Apple Store and the Google Play, so that in a way they indicate values there for not just the stars and how people like the app, but also stars telling, okay, is this app actually digitally inclusive or not? And that would be a great bounty to have so that it would push adoption of this multidimensional digital inclusion indicator. Sorry.
I love it. I will do it tomorrow. I love that idea. We haven't done it, but I think it's a great way to also like crowd in, more user experiences. So definitely. And on the first part of your question was more about, just remind me again, sorry.
I understand that it's through the app you collect, or is it an additional survey you have to have completely separate from the design of the app to understand how digitally inclusive the app is, or is it integrated in the app? And how much of extra programming basically is required so that we have this indicator inside the app?
Yeah, that's a good point. So it's not all fully integrated yet, especially the whole workshop focus group kind of, insights after the scoring. So the scoring is all on the app. You can get that quite sort of quick and dirty, assessments. But afterwards, I think the process, the iterative process, it's also a good suggestion how we bring that into the app. You can think about that. Thank you.
Okay. Yeah. So I'm the last person between you and the closure of the session, so I'll keep it very brief. Thanks a lot. I think this was a super long session, 10:30 to 2:30, but I see that quite a few of you have been really engaged. Firstly, I think I must really compliment Jau and the team for putting up such a fantastic program, because we were able to demonstrate the full breadth and depth of what all is happening with respect to digital innovations across CGIAR, right? We started with Boniface, who gave us a flavor of what Kenya has been doing. And then we had Morgan, who was speaking about nudges. Then we had some case studies, Srikant speaking about Plantex, and then I think we also had Alok Sikka and Filco who were demonstrating about digital twins, and then Murali Gumma speaking about yield prediction, so on and so forth. But I think for me, the icing of the cake was the last two sessions, wherein I think we really brought in the angle of citizen science with respect to really powering the digital innovations, because ultimately data is the bedrock of creating any digital innovations, and collecting data is an expensive process. So that's where innovations like citizen science and how do you use citizen science to collect that sort of highly granular data. I think that was a great session to sort of top it at the end of the day. And thanks, Inga. I think before we could all forget, in all this excitement, I think you brought the focus back to the issue of inclusion. Ultimately, all these digital innovations have to lead to a more equitable outcomes, right? We can't afford to, create an innovation that furthers the gender divide and also causes more inequity. That's not our primary objective. Is equitable development, right? So I think with that, that's a wrap. Thanks once again. I hope you have a great rest of the evening and a great weekend. Safe travels, all of you, back to wherever you have come from. Thank you.
Which is clicker. With the CG and Carlo. We want to do joint research proposals and joint research so that it is possible to disseminate these research findings to a wider audience, that is to the farmers. As a partner, we can be able to work together to achieve that goal.
Science Week, and we're very excited that we just launched the new science portfolio for CGIAR. And this portfolio has 8 science programs, 4 accelerators, and 1 scaling program. And the idea is that collectively, this portfolio really aims CGIAR for the future, the next 6 years of CGIAR working together, and also having a collective impact to solve some of the very, very big problems that we have globally. We also want to take the opportunity by doing the science to also help to set the tone of the global science agenda and help to drive that as well. With this portfolio, we have a very big ambition. One of the ambitions, 82 million people out of poverty globally. This is very big ambition. We know that the science and the capabilities in working with over 3,000 partners, we can really make this happen. With science, we can.
It's really a pleasure to be with you here today. I have been wanting to really bring the community together since the first day with CGIAR. And the reason behind is I believe in science. I believe science voice have to be the loudest. We have to spotlight knowledge and we have to use it.
Kenya is proud to host this landmark event focusing on innovation and partnerships for food, nutrition, and climate secure future that brings together the world's leading minds in agricultural research, innovation, and policy. Let me take this opportunity on behalf of the government and the people of Kenya to welcome you all to Nairobi, especially those delegates who have traveled from across the globe. Karibuni Kenya, the cradle of humanity and a hub of innovation in agri-food systems.
What we want is a positive impact on the global food security. Impact starts with insight, and I love it. Really, that's what science is. It brings us insight on issues so we can have the impact that we are looking for. We all agree that food security cannot happen without science, without research, without data, without analysis, without innovation, without intelligence. We still have global food and water emergencies that we need to address. But we are also facing climate change, biodiversity loss, and new conflicts. Once again, we must build capabilities to be able to address these new problems. We have done it before, and I'm very confident we'll do it again.
Climate change is a very big challenge to agricultural systems across the world. And to be able to tackle effects of climate change, we need a lot of partnerships, a lot of collaborations. With partnerships, you are able to pool resources, expertise, knowledge, and data. And that way, research becomes efficient, effective, and sustainable going forward. A lot of work has been done, but it is not out there with the stakeholders, with the farmers. So I hope this will be an opportunity to showcase all the technologies, innovations, management practices that has been developed through partnership with the CG and CALRO. We want to do joint research proposals and joint research so that it is possible to disseminate these research findings to a wider audience, that is to the farmers. As a partner, we can be able to work together to achieve that goal.
Science Week, and we're very excited that we just launched the new science portfolio for CGIAR. And this portfolio has 8 science programs, 4 accelerators, and 1 scaling program. And the idea is that collectively, this portfolio really aims CGIAR for the future, the next 6 years of CGIAR working together, and also having a collective impact to solve some of the very, very big problems that we have globally. We also want to take the opportunity by doing the science to also help to set the tone of the global science agenda and help to drive that as well. With this portfolio, we have a very big ambition. One of the ambitions is to actually relieve 82 million people out of poverty globally. This is very big ambition, but we know that the science and the capabilities in working with over 3,000 partners, we can really make this happen. With science, we can.
It's really a pleasure to be with you here today. I have been wanting to really bring the community together since the first day with CGIAR. And the reason behind is I believe in science. I believe science voice have to be the loudest. We have to spotlight knowledge and we have to use it.
Kenya is proud to host this landmark event, focusing on innovation and partnerships for food, nutrition, and climate secure future that brings together the world's leading minds in agricultural research, innovation, and policy. Let me take this opportunity on behalf of the government and the people of Kenya to welcome you all to Nairobi, especially those delegates who have traveled from across the globe. Karibuni Kenya, the cradle of humanity and a hub of innovation in agri-food systems.
What we want is a positive impact on the global food security. Impact starts with insight, and I love it. Really, that's what science is. It brings us insight on issues so we can have the impact that we are looking for. We all agree that food security cannot happen without science, without research, without data, without analysis, without innovation, without intelligence.
We still have a global food and water emergency that we need to address. But we are also facing climate change, biodiversity loss, and new conflicts. Once again, we must build capabilities to be able to address these new problems. We have done it before, and I'm very confident we'll do it again.
Climate change is a very big challenge to agricultural systems across the world. And to be able to tackle effects of climate change, we need a lot of partnerships, a lot of collaborations. With partnerships, you are able to pool resources, expertise, knowledge, and data. And that way, research becomes efficient, effective, and sustainable going forward. A lot of work has been done, but it is not out there with the stakeholders, with the farmers. So I hope this will be an opportunity to showcase all the technologies, innovations, management practices that has been developed through partnership with the CG and Carlo. We want to do joint research proposals and joint research so that it is possible to disseminate these research findings to a wider audience, that is to the farmers. As a partner, we can be able to work together to achieve that goal.
Science Week, and we're very excited that we just launched the new science portfolio for CGIAR. And this portfolio has 8 science programs, 4 accelerators, and 1 scaling program. And the idea is that collectively, this portfolio really aims CGIAR for the future, the next 6 years of CGIAR working together, and also having a collective impact to solve some of the very, very big problems that we have globally. We also want to take the opportunity by doing the science to also help to set the tone of the global science agenda and help to drive that as well. With this portfolio, we have a very big ambition. One of the ambitions is to actually relieve 82 million people out of poverty globally. This is very big ambition, but we know that the science and the capabilities in working with over 3,000 partners, we can really make this happen. With science, we can.
It's really a pleasure to be with you here today. I have been wanting to really bring the community together since the first day with CGIAR. And the reason behind is I believe in science. I believe science voice have to be the loudest. We have to spotlight knowledge and we have to use it.
Kenya is proud to host this landmark event, focusing on innovation and partnerships for food, nutrition, and climate secure future that brings together the world's leading minds in agricultural research, innovation, and policy. Let me take this opportunity on behalf of the government and the people of Kenya to welcome you all to Nairobi, especially those delegates who have traveled from across the globe. Karibuni Kenya, the cradle of humanity and a hub of innovation in agri-food systems.
What we want, it's a positive impact on the global food security. Impact starts with insight, and I love it. Really, that's what science is. It brings us insight on issues so we can have the impact that we are looking for. We all agree that food security cannot happen without science, without research, without data, without analysis, without innovation, without intelligence.
We still have global food and water emergencies that we need to address. But we are also facing climate change, biodiversity loss, and new conflicts. Once again, we must build capabilities to be able to address these new problems. We have done it before, and I'm very confident we'll do it again.
Climate change is a very big challenge to agricultural systems across the world. And to be able to tackle effects of climate change, we need a lot of partnerships, a lot of collaborations. With partnerships, you are able to pool resources, expertise, knowledge, and data. And that way, research becomes efficient, effective, and sustainable going forward. A lot of work has been done, but it is not out there with the stakeholders, with the farmers. So I hope this will be an opportunity to showcase all the technologies, innovations, management practices that has been developed through partnership with the CG and Carlo. We want to do joint research proposals and joint research so that it is possible to disseminate these research findings to a wider audience, that is to the farmers. As a partner, we can be able to work together to achieve that goal.
Science Week, and we're very excited that we just launched the new science portfolio for CGIAR. And this portfolio has 8 science programs, 4 accelerators, and 1 scaling program. And the idea is that collectively, this portfolio really aims CGIAR for the future, the next 6 years of CGIAR working together, and also having a collective impact to solve some of the very, very big problems that we have globally. We also want to take the opportunity by doing the science to also help to set the tone of the global science agenda and help to drive that as well. With this portfolio, we have a very big ambition. One of the ambitions is to actually relieve 82 million people out of poverty globally. This is very big ambition, but we know that the science and the capabilities in working with over 3,000 partners, we can really make this happen. With science, we can.
All right, good afternoon, ladies and gentlemen. Welcome to day 5 of an amazing week that we've had here at Science Week, thanks to CGIAR and our host here at UNON. I'm about to call the room to order, so please take your seats and we can begin this penultimate day. Thank you so much for being with us. I hope you guys have had a fantastic week, both on and off the campus. If there's an overflow, folks, I know this room is packed to the rafters. There's an overflow in conference 4. Please feel free to use that, and it'll be just as good. I hope you guys have had have you guys had a good week? Have you had a good week? Have you? Yeah. These people in the middle have not had a good week. They're not clapping. What's going on here, man? What's going on? Not enough places to go visit in Village Market and have a good time, or what happened? Have you had a good week this week? Make some noise. All right, thanks so much, folks. Thank you. Honorable Dr. Paul Kiprono-Rono, Principal Secretary, the State Department of Agriculture. Dr. Ismahan El-Wafi, Executive Managing Director, CGIAR. Lindiwe Sibanda, Chair of CGIAR. Ambassadors, High Commissioners, scientists, innovators, young people, ladies and gentlemen. Welcome to day 5. My name is Jeff Konenge. I've been telling you all this in case you just forgot, but I got to remind you just in case. And listen to some of these statistics before I call out my first speaker. Listen to some of these statistics this week. It's been incredible. There's been 5 plenaries all week. There's been 92 events, 13,600 registered participants, more than 100 countries represented. Thousands of young people. And when it comes to social media, folks, it's been smoking. More than 20 million impressions. And that's why I say, let's take it to the finish line and keep using those hashtags, okay? Hashtag Science Week, hashtag CGIAR Science Week, hashtag With Science We Can. Let's do that, folks. And I'm telling you, the thousands online and many more will know that Nairobi was the place to be. Congratulations to all involved. Congratulations for coming. Congratulations for turning up, everybody. And we're going to take it all the way to the finish line. And to start that off, I'd like to ask our host, Dr. Ismahan El-Wafi, to come to the stage and say a few words about her and her team. Doctor.
Thank you very much, Jeff. As I said at the beginning, I really wanted to bring the community together from day one. And that's, in my view, that was a vision. But that vision wouldn't have been possible without a number of people around. There was an amazing team that was behind it. So let me first thank my colleague in the global leadership team, but really the team that did the work this week. I want them to come up, as we call them, and have a group photo before we go to the closing session. And those, I would like to thank everybody that showed up, from all of you, people that are online and have been following us for a week. the numbers, the 13,600 people that registers to be part and parcel of the Science Week, it's a huge number. It shows that people are thirsty for science. People are thirsty for good news as well. They're thirsty for hope, and that's what science brings. And that's what CGIAR brings, solutions to the country level and the community where science could really thrive and work with each other. So let me call on the stage the tag team, Eric, Simon, Leah, Lily, Tanya, Givan, the event agency who did all the production and logistic work. Please. The Yunnan team, DJ, Nadia, Nelson, Shannon, Wilfrida, Josephine, and many others. Please join us on the stage. Emerging tag team, Rubin, Lufingo, Omar, Katrina, Wiganjo, Chloe, Sophie, Madi, who were in charge of the plenary program. The program and accelerator communicator who promoted the new portfolio for CGIAR 2025-2030, Evan, Gina, Abukun, Karen, Wandera, Simon, Roby, Isha, Barbara, Julie, Jeffrey, Marta, Mahereen, Riz, Raji, Nathan, and Bobby. The Calgaro team, Dr. Eliud, please come and join us. Philister, Evan, Freda, Lusike, Caroline, Florida, Kipkemori, Carl, Margaret, David, and Steven, Miriam from Ilri, and Moses from Summit, who coordinated the exhibition area and the field trip. Please join us. Very special thanks to Ilri operation, procurement, security, communication, corporate, and leadership team who did a lot of the heavy lifting and which are too many to name. Please join us. All the CGIAR centers and system organization staff here and working remotely, thank you so much wholeheartedly. The Small and Mighty CGIAR Global Campaign event, Ruti, Debbie, Vanessa, Catherine, James, also the Muscle and Embodiment of Science Week, Natalia, and Nathan, who was leading all of this work. Very good. Picture? Yeah. Yes. Thank you very much for everything you did. And now we'll start the closing session. Thank you.
Thank you, Dr. Islam. Well done. Great team, great week. Well done, guys. Another round of applause, ladies and gentlemen. Well done, guys. Is it just me, or does nobody ever ask or thank the MC for these? I mean, did these sessions drive themselves?
Jeff, I was leaving you to the end.
Oh, okay. My bad. I just felt a little left out of the photo. Dr. Islam, no pressure. I'd like to call on stage right now Dr. Eliud Kiplimo Kariga. He's the DG and CEO of CalRO on stage, please. Dr. Kirega. And Dr. Rachel Chikwamba. She is the Chair, Science, Innovation, Impact, and Partnership Committee of the International Partnership Board at CGIAR. Welcome. And before we get to you, a couple of things, I'd like you all to turn your attention to the screens behind me. There's a message. First one up is Her Excellency Amina J. Mohammed, Deputy Secretary General of the United Nations. Let's take a listen.
Excellencies, ladies and gentlemen, it is a pleasure to join you at this inaugural CGIAR Science Week in Nairobi. You're coming together just a few months ahead of the second UN Food System Stocktake +4, which will be held in Addis Ababa at the end of July. At the stocktake, we will have the chance to reflect on the progress we've made and, more importantly, chart the way forward. Progress on the SDGs requires accelerating the transition to sustainable food systems. Partnerships are essential in accelerating progress, bringing together diverse expertise to drive science-based solutions. By aligning research with policy and action and working with partners like CGIAR and the high-level panel of experts of the Committee on the World Food Security, we are building food systems that are resilient, sustainable, and inclusive, ensuring lasting impact in the face of climate change and global hunger. Yet we must also remain mindful of the challenges we face: geopolitical tensions, the impacts of climate change, economic uncertainty, and the urgent need for a reformed international financial architecture that supports these efforts. Today, 1/3 of the global population remains food insecure. Our food systems, responsible for 1/3 of global emissions, struggle to meet the growing nutritional demands of our communities. The urgency of addressing these challenges has never been clearer, and science must be at the heart of the solutions that we seek. It is critical that we leverage the full potential of science to drive the policies, the innovations, and investments that are essential to accelerate the changes we need. We must act with a sense of urgency in a fully integrated manner, scaling our efforts to meet the needs of those who are most affected by hunger, malnutrition, and the ongoing climate crisis. With only 5 years left to achieve the SDGs, multilateral platforms such as the Financing for Development Conference, the UN Ocean Conference, and the World Social Summit are key to advancing our shared goals. These forums offer us invaluable opportunities to come together, build partnerships, and align efforts to tackle hunger, malnutrition, climate change, and land degradation. I look forward to the outcomes of this Science Week, especially as we strengthen partnerships, inspire action at scale, and invest in science that can build resilient, equitable, and sustainable food systems. Together, we do have the power to shape a future where no one is left behind. I encourage you all to bring the results of this week, your knowledge, and your experiences to the upcoming Food System Stocktake. Let us move forward, united in our commitment to a more sustainable and inclusive world for everyone. Thank you.
I'd like to invite Dr. Eliud Kiplimo Kirega to come and say a few words. Karibu.
Thank you very much. Reflections for the week. The Science Week provided a critical platform for dialogue, collaboration, and innovation, bringing together global leaders, researchers, and partners to address the pressing challenges of food security. The discussions underscore the role of science, technology, and partnerships in transforming food systems for a more sustainable and equitable future. This can be summarized as follows. One is the significance of CGIAR Science Week as a global collaboration platform in bridging critical sectors. The event has uniquely convened agriculture, climate, and health stakeholders to address interconnected challenges threatening food security and sustainability. By integrating these domains, we have moved beyond siloed approaches to systemic solutions. Two, in accelerating innovation. The Science Week showcased transformative tools from AI-driven agricultural decision-making to climate-smart crop breeding technologies that are ready for scaling. These innovations provide actionable pathway to resilience. Therefore, the next steps for momentum include regional scaling, that is, prioritization of localized adaptations of proven technologies, particularly for smallholder farmers. Two, in terms of policy integration, working with African governments to embed Science Week outcome into national agricultural strategies, leveraging CGIAR's partnerships across the 100+ countries it operates. In terms of youth and gender focus, expansion of programs like the innovation showcases to empower women and youth as drivers of agri-food transformation. In terms of strategic partnerships and CALRO, our commitment is that the event has fostered partnerships in two major areas of focus. One is public-private synergies. Networks have been initiated and renewed, and alliances forged between CGIAR centers, CALRO, and agribusinesses to commercialize climate-smart and water-efficient technologies. The second one is South-South collaboration. This forum has also strengthened knowledge exchange with global South research institutions to address shared challenges like soil degradation and pest resilience. In terms of CALRO, what did we do over the week? CALRO has played a critical role in three key areas. Technology bridging. It was demonstrated at field visits to our centers how CALRO's adoption of CGIAR-developed heat-resistant wheat varieties and climate-smart irrigation systems directly benefits Kenyan farmers. Two, as demonstrated in the exhibition, CALRO has launched partnerships to disseminate innovations through mobile platforms and local cooperatives, ensuring accessibility for marginalized communities. What is our future commitment? So CALRO's future commitment comprises of the following. One is research prioritization. CALRO's strategic plan 2023, 24, 27, 28 will be aligned with the CGIAR portfolio focusing on AI-enabled pest forecasting and major pest soil restoration, amongst others. Second commitment is that we will champion increased funding for collaborative R&D as emphasizing return on investment from projects like drought-tolerant maize hybrids, which boost yields by more than 40% in arid areas. In closing, this Science Week has reignited our collective resolve to transform food systems through science. CALRO commits to being the bridge between global innovation and local impact, ensuring no farmer is left behind in the climate crisis era we are in. Thank you very much, and God bless all of you.
Thank you very much, Dr. Eliud Kiplimo Kirega. I appreciate that. Next, I'd like you to turn your attention to the video screens behind me once again. We'll have a video message from Dr. Jürgen Vogele, the CGIAR System Council Board Vice President for Sustainable Development at the World Bank. Take a listen. Take a listen.
Good afternoon, friends and colleagues. It's been an exciting and extremely busy week for everyone. The world around us is changing rapidly with significant implications for the CGIAR. And I'm sure you have spent a lot of time discussing this in detail this week. Let us be clear. The need for CGIAR's work is stronger than ever. Population continues to grow. Increasingly severe weather events make food production more and more risky, And growing conflict around the world makes more and more people food insecure. And changing trade policies, as we see in the last few days, will affect hundreds of millions of people. At the same time, we see a decline in public spending for the needs of poor countries broadly. That also means competition for scarce research is much fiercer now. For us as a CGIAR system, it becomes ever more critical to have a compelling narrative why investing in agriculture research has the highest return on the dollar and is a key part of the solution to a changing climate, migration, and conflict. We do need to tell a story about how many lives drought-resistant wheat varieties save, or flood-tolerant rice, or nutrition-dense crops. It is impact and scale that matters and will be the most convincing in donor capitals. And we must ask ourselves some fundamental questions. For starters, is our new research portfolio still 100% relevant, or do we need to prioritize even more? Or how can we get more creative about new funding sources and modalities? Or we ask the question, does our business model and how and with whom we partner need a rethink? The new structure of CGIAR is an integrated partnership with its governing board that hopefully come into its own to tackle these new challenges. To CGIAR management, center director generals, researchers, I would like to say, look, the System Council and its members have had your back for over 50 years. That will not change now that the going has become tougher than usual. And the need for CGIAR's work greater than ever before. As everyone returns home and to their day jobs, I would urge you to keep rethinking partnerships, and especially their diversification. Also, please do whatever you can to help governments to repurpose agricultural subsidies and to invest more in agricultural research. CGIAR Resource Management seek and develop innovative financing solutions, partnerships with non-traditional government funders, philanthropies, and sector investors. For the CGIAR research leaders, prioritize best bet solutions with highest returns to scarce resources. We cannot do everything. We have to be selective, and we need to really be very deliberate. And for CGIAR researchers, find ways of sharing costs and expertise across more diverse partners, including private sector, and concentrate on exploiting comparative advantages wherever they can be found. Now, my final takeaway message is that we must all pull together traditional funders, new funders, including more. The CGIAR integrated partnership board needs to model a cast iron partnership across all CG centers, enabled to work with a broad array of external partners to exploit each and every individual competitive advantage. I frankly have no doubt that together we can do this. So I wish you a good weekend and a safe journey home.
And last but not least, ladies and gentlemen, please welcome Dr. Rachel Chikwamba.
Excellencies, ladies and gentlemen, I rise on the protocol that has already been observed, and I hasten to thank the MC, lest he should withdraw the mic. On a serious note, since its inception, the CGIAR has shaped global agriculture and food production and the food systems that underpin it, playing a critical role in enhancing yields and overall productivity of food systems, contributing to enhanced quality and nutrition of food, reducing poverty by providing farmers with access to improved technologies and practices that have helped boost their incomes, develop sustainable farming practices that protect the environment, conserve and rejuvenate natural resources.
Okay.
Produce research that has influenced policies and investments that promote sustainable agriculture and food security. These things have been said throughout the week. This is part of the DNA of the CGIAR, but it cannot be said enough. The week that has been a tour de force of a showcase of the things that we have achieved. It has been a preview, an intriguing one, of the things that are possible. In addition, the CGIAR and its partners have built the capacity and skills of researchers and farmers, ensuring the long-term sustainability of its work. With the rapid advances in technology, The CG continues to harness advanced and emerging technologies in pursuit of our mandate, and we've witnessed this in the past week. With its partners, they have demonstrated over the course of the week that they remain committed to and are on track to deliver on the mandate and to support the transformation of agri-food systems to deliver food security, economic stability, gender equality, and climate resilience. To this end, the role of partnerships in co-creation and co-implementation is a critical condition for success, and it came up a lot in our conversations over this past week. Partnerships between the private and public sectors, the CGIAR and national and regional organizations, UN agencies, universities, as well as partnerships with farmers were highlighted. On the latter, we heard that the voice of farmers has become paramount. Gone being the days when farmers were just recipients of innovations, to now an era in which they have become a critical partner along critical elements, in fact, of the innovation value chain. Partnering strategically has indeed been a recurring message throughout the week, especially as we seek to build and transform farming systems in the context of the current global climate, where climate change continues to be difficult, instability is an issue, the funding landscape is not the same. The CG is uniquely positioned to serve and complement ongoing initiatives through its extensive network of partnerships, and it remains a leader in fostering collaborative efforts to address these seemingly intractable global challenges. They have done this over the past 50 years in a shifting environment, and they continue to do this so very proudly, as we have witnessed this past week. Throughout this week again, the CG has articulated its vision to build, consolidate, and nurture partnerships that drive meaningful outcomes. And its commitment to enhancing research, innovation, and scaling capacities through mutual learning and co-development was really emphasized. For the youth that are in the room, I hope you have been inspired. And I do hope you take up careers in science and technology. In particular, you take up careers in agriculture. You have seen what is possible. You have seen the role of technology therein. You have seen its potential to transform not just our lives, but indeed how we engage the youth and how the youth can take charge of our common destiny by really being involved in what future belongs to them. As we look again to the future, we look forward to working together to address these global challenges through the CGIAR 2030 Research and Innovation Strategy, which again demonstrates commitment to integrated systems research to create sustainable and resilient food systems underpinned by solid science and evidence for policy development. Importantly, a clear case has been made for sustained global investment in research and science. Our partners have had our back for the past 50 years, I just heard, and they continue to have our back. Investment has continued to support us in innovating and in scaling the work that we do and in realizing the impact that has transformed food systems to date. We call upon our partners to continue to support us. Partners old and new, if you can enhance your investment in the work that we do to transform and build resilience and sustainability, particularly in the local food systems. I thank you.
And thank you, Dr. Chikwamba and the CGIAR board. Thank you very much. Thank you, Dr. Kirega and Carol. Appreciate it. You may take your seats. Thank you very much. Once again, round of applause for our speakers right here. Our next session is entitled Remarks from Center DGs. I'd like to call on stage Dr. Apollinaire Jikeng, who's the Director General, International Livestock Research Institute, that's ILRI. I'd like to call Dr. Bram Goberts. He's the Director General, International Maize and Wheat Improvement Center, that's a CIMIT. I'd like to call Dr. Yvonne Pinto, Director General, International Rice Research Institute, that's EME. And I'd like to call upon Dr. Sandra Milach. She's a chief scientist at CGIAR. And this session will be moderated by none other than Dr. Ismahan Elouafi, Executive Managing Director, CGIAR. Dr. Ismahan, you have the floor.
Thank you so much. Thank you very much, Jeff. Thank you very much to the closing remarks. I think we heard some great insights and some great questioning as well. Are we doing well? Could we do things differently? And I want to really pick the brain of these 4 leaders in science and in CGIAR to give us their views. So the first question, reflecting on this week's discussions, did you receive any feedback or insights on the portfolio approach that could help shape its future implementation in your region? And I would like really to call on Bram to start us on this question.
Thank you very much. And I want to give you 3 insights that I think we need to take forward when we want to deliver on that excellent portfolio that was presented so eloquently by Sandra. Number 1, partnerships. Partnerships that can allow us to incorporate local knowledge, design therefore context-specific solutions that have impact on livelihoods, value change, but especially are taking into account systems thinking. And the system thinking requires us to now step into a mode of design thinking, transformational scenario building, where we can really from the future backcast to the present. And this is where we need to incorporate also all the young scientists and capabilities so that we can activate the data and be locally relevant. Thank you.
Thank you very much, Bram. What about you, Yvonne? What do you think? Have you heard things that make you change the pathway we are going, or reinforce your ideas around the portfolio and the way we are implementing it?
Thank you, Ismahan. I just want to say, what a memorable event. Great platform, global in its nature, very exciting to have so many people here face to face, building that connection, which you really have successfully delivered, learning a lot and great conversations. And I'm privileged to represent the Asian region here. So let me offer a few perspectives from there. From the portfolio perspective, if the CGIAR is going to transform land, water, and food systems, it must not underestimate water. In Asia and in Africa, water can cause food systems to collapse through water risks, climate change, and new science and a new generation of innovations are required for future water security. It can also catalyze transformation, changing access and increasing opportunities for smallholder farmers by lowering their water risks. I think also real emphasis on climate resilient crops from the drier regions, especially the dry lands. They're getting drier and more degraded, and we need more nature-friendly agricultural solutions. In relation to the portfolio overall, you've heard it several times, strengthening our partnerships, but rethinking development finance at its broadest level and improving the transparency and accountability by which we deliver that and ensuring that the evidence speaks for itself.
Thank you very much, Bram and Yvonne. You brought in the need for a system level. You brought in the need to rethink the way we partner. And that takes me to the next question. And also the system chair, the system council chair mentioned it. We need to rethink our partnership. So how do you see us putting it in motion, Apollinaire and Sandra? So do you have new ideas of how we can partner better so that we get to the impact that we are striving for, that Sandra presented to us, which makes me scared. So yesterday I couldn't sleep because those number of 182 million people pulled out of malnutrition will be chasing all of us. So it's not only us, it's CGIAR with partners. Over to you, Apollinaire. What do you think?
Thanks, Ismahan. It's my great pleasure to be on this panel. But before I do that, I once again want to thank the thousands of people who trusted that we had stories to tell them. And I think that's really important. And I want to thank you all in the room here for coming to Nairobi, staying with us up to delivering this last mile. I sit here on behalf of a few other colleagues. Babu Kamani, the Africa Rice Director, Simeon Ewi, the International Director of the IITA, Ali Abu Sabah for ICARDA, Elian Elijubaro for C4 ICRAF. We are the collective voice of the CG in Africa. What I'm going to say here is really reflecting how we see the CG in Africa. But the CG in Africa has been domiciliated more than 50 years of our presence here. How can we partner? We've been partnering, and this year, the CGIAR presence in Africa is authentic, must continue to be long-term, otherwise we will not do that. We have to see our partnerships as not just a short-term transaction, it's long-term engagement. We're in this because we complement each other, we co-design, we co-implement, and when we scale together. In Africa, I think it's very important for us to celebrate some of the things that are really helping us to work coherently. Earlier this year, we celebrated and launched the CAADP Declaration in Uganda. It's a framework within which the collective CGIAR family can come together to deliver innovations that are needed. And throughout this week, we've heard that, we've testified that everyone has a piece to contribute. Moving forward, I think the dimension of co-creation of our research, share accountability and responsibility, ecosystem thinking, bringing the youth, gender inclusivity, although in some spheres we shouldn't say it, but we should proudly continue to say it because it helps us to move the agenda and to innovate. And the private sector is a dimension that we have to bring into the discussion. When we say we are partnering, how we engaging with the private sector. Africa is the next frontier. To push the boundary is going to be here. We have to make our science attractive to those who have been funding traditionally. We have to make our science attractive to the private sector to invest in the technologies and the innovations that we are trying to develop. Partnership is about creating incentives. Why are we partnering? The DG of KALRO demonstrated how KALRO and Kenya as a country has benefited. The more we continue to partner through incentive development, the better we'll partner. But it's a long-term engagement. Thank you.
Thank you so much, Apollinaire. Sandra, what about you? How did you hear anything in terms of partnership and mechanisms of working with our partners?
Yeah. First of all, I want to thank the scientists who came and engaged this week. It was a fantastic week, a lot of science from lots of places. I think overall, I think we have more than two-thirds of the presence here that were outside CGIAR, which gave us a lot of insights on how we can move forward. And I heard three things for me that were very important. First, the urgency for science solutions. We all have a common understanding that we cannot stop, that we really need urgency to make things happen. We need to get busy as soon as we end here. We need to go back to our institutions, to our places, and get going with urgency. The second thing is that we cannot go alone. We need to go together. We need to work together because our ambition is big. Our resources are decreasing, but we need to get smarter, and we only can do it by working together. There's no other way, no other way. So that's partnerships is central. Is like every single event that I participated this week. This came very, very, very clear. And I'm going to add a third one, which I think is the vibrancy of the youth that participated this week. Just incredible. I was so inspired by the energy and by the urgency that they bring and the passion they bring to solve this problem. So really, really, I think it was these three masters for me. We need the vibrancy and the energy of the youth to move this forward.
Thank you very much, Apollinaire and Sandra. Apollinaire, you reminded us how the Kampala Declaration, it's really a framework to work in Africa. And we all know, and I really wouldn't stop citing the study of IFPRI and the fact that, yes, FAO say we need to produce 70% more, But actually, when you look at the distribution, we need to produce more in Africa. The numbers say about 95%, whereas we need to produce about 48% in Asia, 47% in MENA, whereas in the high-income countries, we need to increase productivity by about 2%. I would really call on the colleagues to look at the study of IFPRI that shows that, yes, there is an average, but it's different. And in Africa, Apollinaire, I couldn't agree more with you. We need to co-create, we need to co-design, co-implement together. And thank you, Sandra, for bringing really the urgency as well. So that takes me to the third question to Bram. Bram, we talk a lot about South-South triangular cooperation. We talk about different continents, and you are representing the Americas continent. Yvonne is representing the Asia continent, and Apollinaire, the African continent. What are, from your perspective, the most significant challenges that CGIAR faces in delivering impact in the Americas?
Thank you. Yes, in speaking as a representative of those centers in the Americas, SIP, IFPRI, the Alliance, and CIMID, I think the challenge is to keep delivering to farmers with excellence. Because it's only if we can turn what we do into excellent delivery for those farmers that we can maintain the returns on investments that we have had to date, that we can maintain the $70 to $100 of investment for our wheat efforts, or the $25 to $37 for every dollar invested for the wheat efforts. And that's in the Americas. For example, also the US, 60% of the wheat comes from the CG efforts. And we have a huge opportunity. That opportunity is that science program on scaling. We need to get that right. And I think that is a huge challenge to get it right, because that doesn't mean the CGIAR is going to scale. It means we need to create that interface where we can come together with the last mile, with the first mile delivery partners that are next to the farmers, that can translate their needs and connect it to what we can deliver. Now, that's a huge opportunity. We have models that work. We have Masagro in Latin America. We have the consortium around Latin America beans that has been set up. We have the potato consortium and the connection to ecotourism and how that can set up innovations. So how can we take Masagro to Masagro Africa? How can we learn from TAT? How can we learn from Agri-Lac, from UU? All those models, we need to take the opportunity to do South-South learning. And of course, coming from Latin America, that call to not forget in that South-South learning, that continent. It's a continent with biodiversity. It's a continent with environmental services. It is a continent that feeds the world. It's a continent that can offer. It is a continent that can learn. It's also the continent that has very strong host countries. And I really see a role for those host countries that came together during the lunch to articulate what they need for their country plans, so that we can take that into account in those scaling programs, because scaling doesn't happen in a vacuum. It happens with real people sitting in a real context, sitting in a real ecosystem, sitting in a real country. So with that, those host countries coming together and being a space of exchange, another space of South-South collaboration, a space full of opportunity. It's also going to be a space full of challenges. But I think if anywhere we can overcome those challenges, it is in this conversation.
Thank you very much, Bram. On the same question, Apollinaire, would you like to give us your views?
So I fully agree and endorse what Bram has mentioned. I have 3 additional points that I would like to mention. The challenges that we anticipate, many have been indicated. Funding predictability and flexibility, as I think that's really important. We need resources, predictable and continuous resources to do this. On this, I want to thank our funders who have really stood with us. Notwithstanding the current challenges, we have to appreciate the funders that we have. Many of our funders are in this room here. I could cut the check and say, go to Nairobi, do your science week. Being here is understanding, interacting with us, sharing with us, and aligning strategies and hearing where we are about to fail, how we are succeeding, how we can pivot resources to do better and do more. I think funding predictability and flexibility and continuity are going to be important challenges to address. The second one is building national capacity. Without that, we cannot go beyond the CG. And we've demonstrated that it is possible. We have to build the capacity, we have to share the capacity, we have to sustain the capacity and maximize on the capacity that exists in the countries. Without resilient, empower local partners, the CG cannot succeed. The last one is really the agility of our research agenda. Our research has to be focused on real-world application. It's not just a scientific exercise. I'm a scientist, but I want my science to be about developing solutions, which means what is true today may be no longer true tomorrow, which means we have to change course. We have to adjust the way we do things. These are the three challenges that I do anticipate, building on what Bram has mentioned, looking into the future.
Thank you very much. And I'm sure if Yvonne had some time to add, she will also go along the same lines. But Yvonne, you spent the whole week here. We had a global leadership team or retreat together before. What stand out for you? What would you take back to you to Philippines? I know you are flying right back home.
Thanks, Isfahan. And I also want to just acknowledge the centers I represent. So IMI with Mark Smith, ICRISAT with Dr. Himanshu Patak, World Fish with Essam Mohammed, and of course, IRI. What I want to say is, taking back, I think there are still things that we need to do really differently. We really need to transition from isolated initiatives to a value chain of action to deliver. And that really needs to be focused on what we're seeking to do in line with what host countries want and deserve. And we need to work together. So we need to build into that notion efficiencies, effectiveness, this precision focus. We have to integrate our solutions. We've got to make sure that there is integration of things like water and drylands. Our climates are changing, and so this notion of mixed farming systems is really alive and well. And what I would say is, next time we do this, let's make sure we get more farmers in the room. And also, let's give youth and young people an opportunity to develop their leadership and show us ways in which we can foster it. Leadership that deals with complexity and understands the trade-offs and drives us for better evidence to understand what works, so that together we get smarter and brighter, and we can influence those funding flows and innovative finances and the multilateral development banks, some of which are here today, and it's great to see them, so that they can partner with us to really deliver that impact. We're all incredibly passionate about it. We need a bit of discipline to tie us together, and we need to hold ourselves accountable. What do we want to deliver, and how do we demonstrate that? And I have to say that one sentence: science has to be at the heart of the solutions. That's what ties us together.
Thank you. Thank you. Thank you very much, Yvonne. And definitely science ties us together. Sandra, what are you taking back to your home right here on the ELRI campus in Nairobi?
Okay, yes, now I'm part of the Nairobi, Kenya family. Yeah, so I moved here a couple of weeks ago, so living here now. For me, CGIAR is a global organization, very well locally positioned to deliver solutions. And for me, collectively, we need to really focus on the impact that we want to make. And I think this week we talk a lot about the new portfolio. And the aim of the new portfolio is really to bring cohesiveness to the science we deliver and the impact that we want to deliver. At the center of this, I would say, is really the farmer, the communities that we are serving. They are the ones who need to be at the center of our attention, because they are why we're here at the end of the day. All of us are here to help them to have food security, to be able to have better livelihoods, to have better nutrition. And while we do that, that really make sure that agriculture brings solutions to the planet. There is not a contribute of the planet problems, but really it's a solution for the planet problems that we have. So I think for me, the cohesiveness of this portfolio, the way we're looking science, and the way we're really putting the big ambition and the big problems that we want to solve, that for me is what is the most important message that we all have to take when we go home. The message that I'm gonna take, that we need to keep, and our mission is so important, and we count on all of you guys to really make this happen. It's not, we need the village, everybody to help. Thank you.
Thank you very much. Sandra, while you have the mic, I would need each one of you to give us one key message to this great audience, and we'll go in order as you are seated. So Sandra, go ahead. What's your one key message or one idea you want everybody to really remember from the Science Week?
With science, we can make a difference.
Thank you.
Instead of giving a key message, I want you to do an exercise before you leave. Last opportunity. Look at the person that sits next to you at the left side. It's difficult. Look them deep in. Look at the one at the right side. It's that the left. That is in the science area. It's always a very difficult exercise. All right. All right. Now that you have done that, did you notice the potential in this room? Did you notice the smart woman that was sitting next to you? Did you notice the man that was charged with talent sitting next to you? So the good news is this room sits chock full of potential. The bad news is we haven't fed one family with potential. We haven't improved one livelihood trajectory with potential. For that, we need to step up collectively. For that, we need to take the collective decision that we can shape and write a new paradigm of science and innovation for development, a new paradigm of a global conversation around our development pathways that we want to design. For that, we need to step up together. So I hope you're going to enjoy your journey back home, however short or long it is. If it's long, sleep. If it's short, take a breath. Look outside at the landscape. Because as soon as you come home, it's going to be your job. It's going to be our job to turn potential into reality in real impact. Thank you.
So folks, we live in a really challenging world, and the times are really challenging. I would say to us, this is about people. This is about ordinary people living their lives. We are super clever, talented, sophisticated people in this room, but we have to keep it simple because we have to be able to deliver to people who live and scratch a living out of the earth. So we really have to connect with them, and we have to ensure that we are moving from a scientific organization to a scientific development organization. I grew up in Ethiopia during the time of the famine. I knew we can do this together. Let's get together and make it happen.
Thanks for the opportunity to offer these few last words. The CGIAR is more than ever relevant. We've seen that this week. Secondly, Africa is home to the CGIAR. In Africa, we can learn, we can demonstrate, we can actually lead and charge ahead, maximizing on the CGIAR offering. Africa is ready with the potential not only to feed itself, but to go beyond Africa. Food, but also knowledge coming from Africa. Knowledge is what brought us here today. Knowledge is critical, but sharing that knowledge is more powerful than anything. As we go away, let's continue to share generously, and let's continue to live the dreams and the possibilities that the CGIAR family brings to the international agricultural development. Today, we have billions of people who are still hopeless, and that hope can only come from us here. There is no other CGIAR, there is no other construct globally looking at addressing the issues that we are addressing. We have the responsibility. The pressure is there, but we do have the tools and the resources to deliver on that. 2030 is not far away, where we will stop to check how well we've done. But we are on course on some of the things. Remember Nairobi, the Science Week?